Tableau won the Deal of the Year IPO and Acquisitions in the 2020 GeekWire Award. And no wonder it got acquired by Salesforce for 15.3 billion USD. And you know why? Because it already exists in all of the top companies from your Google to Amazon to Facebook. Everyone uses Tableau for data visualization. Welcome to OdinSchool. We bring to you a complete free tutorial on Tableau. In this course, you'll get to learn everything from the basics of Tableau to advanced Tableau mechanics. But before we go ahead, please subscribe to our channel OdinSchool. The best part about Tableau is that it can be used by anyone, from someone who already knows coding to someone who is a complete beginner. It requires no coding at all. And in this video, we are going to be taking you some of the real examples and real life implementations of Tableau. This course will be teaching you Tableau in three components. First, the introduction, where we teach you what is Tableau, how to get your data connected to Tableau, what is data visualization. Second part, the intermediate, where we teach you how to prepare basic charts and visualizations on Tableau. And third, the advanced Tableau, where we teach you more complex visualizations and connecting your data onto a server so that people can view your charts and getting your data completely Tableau ready. After watching this series, you'll be able to connect Tableau to any data source, view and modify your data, create any sort of visualization that you want. Watch the video and start practicing to understand the concepts more thoroughly.
Hi all, welcome to this video session on Tableau. My name is Nagraj and I am a Tableau developer. In this video series, we are going to learn what do you mean by data visualization, what do you mean by Tableau, and how you can learn it in the best way. We are also going to see why Tableau and what is its significance in the process of data visualization. Even before I start with this session, let me introduce myself. I'm a Tableau certified developer with more than 7 years of experience in data visualization and reporting. So let's start off with our first question. Our first question is, what do you mean by data visualization? And I think this is one of the most common questions that I get from freshers, and I'm pretty sure you might have heard these words like data visualization, BI, business intelligence, or Tableau, right? This all words are being a buzzword in the recent past. So what do you mean by all these things? Let's see. Um, Data visualization is the recent adaptation, I would say, which is happening in the data in the business world, but that's something not new to us or not something new to the humankind, human beings. And to this statement I can support with two examples. uh, Even for you, like, you might be thinking, well, data visualization is something new for you, but that's not actually. Data visualization is been around us for quite a long time. It's just that we haven't coined that, hey, this is data visualization. It's just that we are so used to for that we never felt, okay, this is also called, or this can be also bucketed as data visualization. If I have to give you the first example is the maps, right? So what is a map is a pictorial representation of a geographical location, right? But imagine the same thing, we used to have it in our geography books as some information, and we have to write books, like we can write books and books on what is it all about, and yet the end user who is going to read that may or may not understand all the things precisely, right? But on the other hand, the same, if you give them as a graphical notation or a map, the user can understand much more better. It's just like the phrase, um, the quotation which goes like, a picture is worth more than 1,000 words, is just so true in this data visualization space. And I think that's the crux of the BI as well, or the data visualization as well. um, Let me show you one more example, which is again from our childhood, and every one of us can relate to, is your chemistry classes and your periodic table from chemistry classes, right? I hope you guys can remember it. So what was the periodic table all about? It's a pictorial representation, or it's a table in which you represent all the elements in a specific structure or in a specific relationship, right? And sorted according to a certain criteria. Now, the same information we used to have it in our chemistry books as volumes and volumes of books, right? So data visual, and now I hope you can connect the dots now. So what is the data visualization? It's like you will have tons of information with you. You will have like millions or billions of records, right? The same example like the chemistry one which I was saying, like the earth is like it's made up of so many things, but if you have to narrow it down, it just comes down to that 105 or 115 or 18, whichever, according to the various authors, or they used to say various terminologies. Like it's made up of just find this limited number of elements, this whole world, right? So you are representing all the things which are made up on this earth in the smallest possible format. Is the same thing that you're going to do with your data as well. You are going to show the entire, like you may have millions or billions of records, you're going to convert them into some pictorial representation, and which can be a precise, which can just fit one screen or couple of screens length, which business can consume and make more strategic and more data driven decisions. Now imagine from a common man's perspective. Earlier we didn't had this much of data with us. The data was quite limited on the digital side. All the information was stored in physical, like books kind of thing, or handbooks or hand materials, or many a times the information was not noted at all, right? But now everything is getting digitalized, and hence you're getting all the information in one place in as a central repository. The quality of the data is different. Okay, that's a different discussion altogether, but we are having all this data which can be used to make much more finer analysis. Now how can you make, now if you are not from a reporting background, and if you are wondering, okay, what is a data benefit, like what can data help you to make business decisions? um, I'll take a very common example. Now imagine a situation like there's someone who is MBA passed out from a very beautiful college, and now he feels, okay, I can make a very good business in hotel industry, right? He wants to open a hotel, but now he is not sure on what kind of food can be served on which day, right? But let's assume if he has information of some hotel which is already existed in the market for a quite a long time, he can look at the data of how the customers visited. He can see at what point of time people were ordering what kind of food. Let's say on the weekends, there were more of the fancy dishes which were being sold. On the morning hours, it was mostly the breakfast related. In summers, there are some more beverages or ice cream related stuff, and so on, right? So those insights can be made out of your data. But imagine if I'm running a hotel for let's say some 10 years or 20 years, imagine the amount of data that will I will have at my disposal. And imagine if I have to scroll down the data and make some decisions, it's like nearly impossible, isn't it? So in these situations, you need some tool, or you need some intermediate process which can help you to analyze such huge amount of information, right? So what do? We take all that information and we dump it into the tools like which are called as the BI tools, which can be like Tableau, Power BI, Click, and many other tools which are there. And once you dump this information, Now you have the flexibility to aggregate those informations, and you can just have some charts or visual representations. And now, I'm sorry, this visual representation can help you to analyze the information more correctly. You can do the insights, you can find the correlation, you can find out any trends hidden in it, and thus you can make much more data driven decisions. And this is where it comes from. When any like anywhere if you hear saying that people make data driven decisions, this is what the rationale goes behind the scene. Now, this is all about the data visual, not all about, but it's a very brief about data visualization. And when we are working on data visualization, it's not that you can just take any information and you can just create some visualization and it's you give it to the user. No, it's not. There are lots of principles which are um there in the space of data visualization, which helps you to make appropriately, like, or which helps you to convey the information, or which helps you to convey your story in much more better format. Like, I'll take a very common example. Let's say red is considered as a bad, or as a not a good symbol, or it's kind of a alert kind of a symbol in most of the countries, right? In most of the geographical area, red is considered as something alert kind of a thing. Now you can leverage that predetermined um, thought process of the business users to show something. Like, if you're trying to show a bar, and let's say if things are not happening good, you can show it in a red color. Let's say if I have met my target, I'll just show it in the green color, so that I do not even have to read the numbers. I can just look at that visuals, and something will strike in my brain, hey, all things look good, or things are not looking good, so like that. So there are these principles which help users, or which can be introduced in your charts or in your visualization, which can make your visualization more effective, more it can like give more stories. All right. Now so that's and these principles are being laid out at different levels and by many different experts. One of them is Edward Tufte, and this is how he describes the data visualization. He says graphical excellence is that which gives to the viewer the greatest number of ideas in the shortest time, with the least ink, and in the smallest space. Now, there are many things which are combined into one statement over here. In the process of our course, we are going to dissect this definition, and we are going to understand what do you mean by each of them. What do you mean by the smallest space? And how is it related to the least ink? What do you mean by the shortest time? Like, you have to give the greatest number of ideas in the shortest time. What does that mean? And how is it really significant? We are going to understand all of them as we proceed in our session, right? So that's about the data visualization. I'm going to cut it short over here, so that you are not overwhelmed with the information in the first instance. So let's quickly move to Tableau, and let's understand what is the role of Tableau in this space. Now, Tableau is a business intelligence tool, which, according to their official definition, you can see it's like it can query the relational databases, online analytical processing cubes, cloud databases, and spreadsheet, which means basically you can connect to any kind of database, and it will consume that data, it will churn the data, and it will give you some beautiful visualizations which can help you to make some more strategic decisions, right? So that's your Tableau. It helps you to convert your data into some beautiful visualizations. And in this process, Tableau offer you various tools and products which you can use. There are few commercial products which are bound with some commercial commitments, but there are also few tools which you can leverage at free of cost, and these tools are especially there for like one of the tool which is like Tableau Public is there for students like you who want to learn Tableau and not necessarily have to pay the cost for the licensing, right? So let's look at each of this tool in a little bit more deeper fashion. So the first tool is Tableau Desktop. This is a place where you are going to spend like nearly 80% of your time as a Tableau developer. It's a local file, it's a local exe tool which you are going to install on your local machine, and the installation is quite simple. We are going to see it in next few minutes. So once you install this file on your local machine, you can connect to the various data sets starting from Excel or a text file or even a PDF, and you can even connect to the databases starting from Oracle to any like Spark or Hadoop or Hive and many other databases. You can also connect them to the online platforms from where you can web scrap the data, right? So that's the beauty of the Tableau Desktop. Once you connect to the databases, you can either have it as a live connection where the data just keeps flowing into your desktop, or you can just create a extract of it, or you replicate the data into Tableau's engine and you can just switch off the connection, and then you can work in offline mode as well. So that's the one of the best part of Tableau's desktop is over the other tools is you can work in offline mode as well. The alternative for Tableau's desktop is Tableau Online. Now, there are few companies who prefer having their data on a Tableau cloud instead of installing a physical server in their office environment. In that situation, you may have to access your Tableau using a web browser. Now, my personal feeling is like when you're working on a web browser and a cloud-based service, there's a small uh, restriction in terms of like you have to rely on technology, or you may have to rely on internet to a certain extent. Like if without internet you cannot work on this kind of services. Also, there are few technical limitations which you will come across when you are using the Tableau's online versus the Tableau desktop. Now, the third tool is Tableau Public. This is the tool which I was saying about. Now, if you compare this screenshot with the previous slide, there's not a much of difference. The tool looks nearly same. It's just there are few features which are disabled so that organizations cannot use it. At the same time, students like you or the tutors like me can use this tool uh, for the learning process, right? So that's the beauty of this tool. I'll share you what are the limitations of it, and I'll also share you how you can use it in the best way. Right. The next tool that we have is Tableau Prep. It's I believe it's one of the recent addition in the catalog of Tableau's product. I think it was released in year 2018 or something, where it's a ETL tool. Now again, a new jargon over here or a new word which you'll come across. ETL. What do you mean by it? ETL stands for extract, transform, and load. It means um, you may have your data sitting across platforms. It may not reside in a single database or a single platform. It may span across multiple databases, and it may be at a different granularity. Like let's say some information is at a consumer level, or some information can be at a city level, or some might be at a state level, right? So you cannot marry all this data together. In those kind of situations, you need a tool or you need an environment where you can just level the field, right? You can just create a data which is just combined from all these different databases. You merge them into one. At times there is also a situation where you have some bad data in it, right? Bad data is like your data was captured incorrectly, or it was captured accidentally, or there are some user, when he's trying to enter some information, he has entered incorrectly. So we may have to clean this data to so that the your process when you're creating your data visualization becomes much more easier, and your Tableau do not have to take much strain to do all this processing. So all this processing, all this cleansing of data is done using Tableau's prep. Now the final one is Tableau server. Tableau server is a central repository system where you are going to upload. In Tableau's world, we call this upload as publish. So you are going to publish all the dashboards, stories, worksheets that you have created onto your Tableau server. And Tableau server, once you publish it to the server, you will get a link which you can then share it with your end users via any medium like mails, chats, or even the WhatsApp, right? It's so simple. And your end user just have to have a good internet connection. He or she should have a web browser, which I assume all the machines will have, and your laptops, desktops, or your mobile phones. And finally, they should have access to this report. So Tableau server also gives you a very beautiful way in which you can restrict the users, or you can restrict any unauthorized access. Now this is one more key benefit of having a centralized repository system versus compared to our legacy system. Let's say if you are reporting in a Excel based environment, what happens is you cannot control where the reports are going. Like, let's say you have shared one report with one of your colleague. Now your colleague can take that report and he can share it with 10 more other people, and you cannot control it, right? Same thing can be avoided to a great extent. I do not say 100%, but a great extent can be avoided using a server where I can restrict the access to only a certain number of people, so that only the people who are allowed to see that report can see it. Any other person, even if he or she has that link, unless you as a developer allow them to see that report, they will not see it. They'll simply get a message, resource not found. That's it. So that's the beauty of your Tableau server. The another beauty or the another benefit that you have is um, you need not need to keep sharing the content every now and then whenever there is a change in your file or whenever there's a new data added, right? You do the changes on your local machine and you simply replace the file which is there on the server, and that's it. Your end user can use the same link and they can access the file, or they can access the new content. There's also a way on the server where you can schedule the refreshes. You can do like if it's a not a live connection, and if it's an extract connection, then you can schedule the refreshes based on your the data availability and the business requirement. You can schedule the refreshes starting from, I think, less than an hour to it can go for a weekly, monthly, or even an annual refresh where you don't have to intervene at all. Tableau will take care of it. So that's the beauty of Tableau server. Now let's look into each of this tool in a little bit more deeper fashion. Even before that, let's try to install Tableau's desktop and let's see how we can do it. Just 1 second. So yeah, so to download Tableau's desktop, you may have to go to its official website, tableau.com/products/desktop. And over here you will see this option, try it for free. Now you can use Tableau for 14 days free of cost, and it's like you get all the features that are there in Tableau's desktop. Commercial process or commercial tool, you can have it here for free of cost. I would recommend you not to install it right now, so that first you can have your Tableau public installed. You can have your hands dirty with it, and in case at a later point of time, if you want, you can use or you can install your Tableau desktop as well. There's also alternative where if you are a student, you can get a student license free of cost for 1 year. Might be I can share that details at a later point of time. You can also have it like for 1 year instead of just 14 days. But for most of the common situations, or for the common working professional, it's a little bit tough to find someone. Like you may be working and you may be also studying, right? So yeah, that's the reason what I suggest for everyone is we can go for Tableau Public. Tableau Public is you can download it from here, from public.tableau.com. If you go to this website, you just have to enter your email ID and you click on this button, download the app. In either of the instances, you're going to get a exe file downloaded to your machine. You just have to open it and just click next, next, next. I don't think there's any customization needed. There's no sophistication in that. You just have to install it, and towards the end it may ask you for a registration form. In either of the situations, you just have to fill it, and that's it. You can get started with your Tableau. Once you start with the download, or like once you have downloaded it and once you have installed it, um, you will get a tool which looks like this. Now this is my Tableau's desktop. You may not have these thumbnails over here. As you start creating your dashboards, you will have these thumbnails being generated automatically, right? Let me show you my Tableau public screen and you can understand what do I mean by that. So yeah, it looks something like this. It will not even have any thumbnails over there. Now as soon as you open your Tableau's desktop, you will have your desktop with this connection page where you can connect to various data sources. The first one is Tableau server. You can connect to Tableau server where someone else or you might have previously published any of the other data sources. You can connect them, or you can also connect to a file, which is a file is nothing but all your local connections, right? It means all your local connections. It means like Excel, text file, JSON files, PDF, any special files. You have your R, Python outputs. You can connect them using a to a file mechanism. The second one over here is to a server mechanism, which means it's a online one. Oops, I think I should have a smaller one. Sorry for that. Yeah, this is an online uh, mechanism where you can um, yeah, so in this online you can connect to the various databases. Like if I have to click on this one, you can see like it's a bunch of drivers that you will get pre-installed. So you may not even need to install any of the drivers if they are the common one. At least from the Tableau side, you may have to install one more driver from the database side, but that's okay. In many of the instances you may not. So you can just select one of them, whichever you want to, and you can just get it going. So let's say I want to connect to my MySQL. So I just have to click on MySQL over here, and I just have to give my user credentials. In case if you need a driver, if Tableau says a driver is essential, you will see over here it says download and install the drivers. Now let me see if I can find something else where you don't need the drivers. uh, 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 um let's see, it's OneDrive. I don't know, or I could have used a better one, which is, let's say, Oracle. Yeah, if you see over here, for Oracle you don't have the install driver option, so it means you can directly establish a connection with Oracle in this situation, right? um, For now, let's connect to a local file which I have it on my local machine. Also, there's one more option over here apart from your, so the first one over here was your to a file, the second one was to a server, this one was your local, this one is your online connection, the third one is your saved data sources. So what happens is, let's say in case if you do not want to reconnect to a same data source again and again, or let's say you have done some changes and you do not want to connect and do that changes again and again, you can save that data source in a specific format inside the Tableau's engine, so that next time whenever you want to access that data, you can just come over here and you can select on this one, save data sources, and that's it, boom, right? So yeah, let's connect to a local file which is a Microsoft Excel. So if I click over here, it will lead me to a new browser, a new window where I can navigate to the place where my desired file is, and I just have to do a double click and I will come to the second page of Tableau. The first page was this one. I will land onto the second page, and over here we can do various connections. Now, this is a place where you do all those connections within the table or within the databases and so many other things. Like this is a place where you do all that data cleansing and everything in case if you're not involving the Tableau prep, or earlier this was the only place where we used to do all that cleansing to at the max level that we can, right? So for now, for our this explanation, let me drag and drop one of the table that I have in this Excel. Now what do you mean by all these things? We will see them once we are exploring the data and the joins process, right? So I'm just going to leave it over here with this one, and then we can navigate or we can move to our sheets, which is the this place. And in the sheets, now you are ready to go. You can create your worksheets, you can create your visualizations, and so on and so forth. So for the simplest example, I can just drag and drop one category. It may take some time because it's the first time I'm trying to create a connection, and boom, my chart is ready. If you feel the orientation is not good, you can just click on this button and your orientation will be done. You want the labels, you just click on this one and your labels are there, right? So it's pretty simple, at least in the initial stages where um, you have very limited depth of reporting. It's like you can make the reports very easily and very fast, right? So this is your Tableau desktop and this is your Tableau public. Now you see there's like virtually no much difference between these two things. The only difference over here you will see is like to a server you'll not find, and save data sources you will not find. um, why? Because Tableau assumes that if you are a learner or if you are a student or if you are a freelancer, you may not have the databases at your disposal, right? Those are very much limited to the business people. So to avoid that kind of misusage, they do not give you those connections, is what my assumption is. However, let's see how we can connect to these files. Like you can just connect to the same Excel or any text JSON, and it's just the same process. Let me see if I can quickly connect to one of them. I just have to click over here. Oh well, we are already navigated to that, so I just have to click on the sample superstore or any other data file, and again the same way I'm going to land on the data connection pane. In the data connection pane, I can just drag and drop it and I have my data connection established, right? The visual looks a little bit different over here because Tableau Public is on the latest version, which is like 2020.2, and my Tableau desktop is 2020.1, which means like I have installed my desktop before March and the public I have installed after March. So there was a new version. So the new version is coming with a little bit different data connection option. I will let you know that details as well. What is the difference between the older tool versus the newer tool once we dwell into the joins and the data connection options, right? Now I can come back to my sheet 1 over here, and you see it's the same thing once again. Again, there's a small change in the 2020.2. So you can use, I can just drag and drop my categories over here, and I can drag my profits over here, and I can just swap it in case if I wish to, and I can click on the labels, and now you see I have two charts just like same, and it was like so simple. It's the process is pretty much simple, and in the next session I'm also going to share you what do you mean by each of this pane, what is the benefit, or what are the different features that you have, like let's say on this drop down, what do you mean by that, what do you mean by the worksheet, what do you mean by data source or dashboards, I'm sorry, what do you mean by the story, and so on and so forth. All right, so we are going to dwell into that. Just hang on, just hang tight. But before that, let me share you the Tableau prep before I get into the online thing. So your Tableau on prep is going to look something like this. It's again an independent tool where you can establish connections, where you can get the data. So these are the different connections that we have. We can keep adding them over here. You can perform some joins, you can perform some cleansing methods, so you're cleaning the nodes over here, you can do the joins and everything. So lots of things that you can do over here. And finally over here you're going to create the final database, which or extract, which then can be connected into Tableau directly. All right, so that's about Tableau prep. Again, I'm not getting into a lot of details of it, but certainly in our next sessions, as and when time comes, we will be dwelling into this in a much more deeper fashion. Now, Tableau online or your Tableau server. All right, this is how your server looks like. um, in each of your sample you will have the workbooks. Workbooks are categorized into the logical departments, which are called as the projects. Projects are again uh, are part of something called as sites, and sites are part of your server, right? So there's a hierarchy over here: server, then you have sites. Inside the sites you have the projects, and each of the projects you have uh, the files. I'll give you a very beautiful anecdote which you can connect to, and you can relate to this mechanism, and you can remember it forever without any tensions, right? So yeah, so that's about your Tableau's server. Now here, as I was mentioning earlier, you can upload the files. If you are uploading any data sources, you can see them here like this, the sample data source. You can see it's in a live mode, and you can also have it in the extract fashion and so on. If I want to see my, oops, I can also go back, I think, over here. If I want to see what are the dashboards that I have, I just have to click on the workbooks. I'll get all the workbooks which are listed over here in my database. If I want to see what are the views, so views are nothing but the each of your dashboard will have the views inside it. So if I want to see them at an individual level, I can just click on the views, and I will have, okay, this is what all of your dashboard is made up of. You want to see any other things, like you want to see all the data sources that you have on the server, you just click on this one and you'll find the list of data sources that you have. Now you can also see on the server, if you are an admin, you can also see what are the schedules which are running. So these are the different schedules that you have on your server, which you can enable for your data refresh, as I was mentioning earlier. Like in case if you're not keeping a live connection and you want to refresh it on a frequent level, you can have that refreshes, let's say either at a daily level, or let's say um, at a weekly level or a monthly level. And I think, yeah, that's the pretty much that you have at least on this server, but you can have as many as you want. If you want some schedules which are not here, you can always talk to your admin team, and your admin team can fix it for you. Like, you want some time, let's say you want once in every 3 days, right, which is not so common. So in those situations, you can reach out to your Tableau admin, and your admin can help you with that requirement. You can also see any jobs which are currently running. So there are no jobs running on my server, so that's a pretty good thing. You can also see, like, if there are any tasks which are being executed, you can have a look on that as well. So there are a few more things on the server. We can also see, like, how you can give permissions, how you can add the users, how you can enable the subscription, the alerts. You as a admin, you can enable or disable the animations, the refreshes, and so many other things, right? So it's again a very deep topic, so might be we will try to touch base as much as we can in our upcoming sessions. um, this is the final one which I want to share for today's session, is your Tableau Online. Now if you see, I've been accessing this Tableau Online using a web browser and a link. So it looks like same like the desktop, right? Like, you can just have your data things over here. You have all your dimensions and measures, your data connections, and all those icons ribbon over here. You have those drop downs, not all of them, but few of them, the page shelf and all the things. Now even here, if I want to create a chart, like, let's say similarly the way I did it on my local machine, I can just drag and drop a few things. I'll just change it so that it looks a little bit more visible. And I can also have, like, let's say minutes of delay over here, and I'll have a chart ready. If I want to see it by some carrier name, I can just put it in the color, and I'll get multiple lines, one each pertaining for each of the carrier, right? So this is how you are going to use your Tableau Online, your Tableau Desktop, and the other tools. Right. So once you create all these charts, the next step is you will have to save your workbook. If you are using the Tableau's desktop, which I believe you will install it for 14 days of trial version, or if you may have the student's account, or if you are a student, you can get your student's license for free of cost by going to their website. But in most of the cases, I believe we are going to use either Tableau's desktop trial version or the public version. Now if you are using the desktop, the process of saving a file is pretty much simple. You do not have to do anything different from the normal behavior. You just hit on the Control S, or you go to these options on the files, and you click on the button on the save or the save as, and you can save the file in either TWB or TWBX formats, and that works absolutely fine. However, if you are working on a Tableau Public, the process is a bit different. What happens is, let me switch myself to a Tableau Public. If you see, this is my Tableau Public over here. Now if I have to save any visualization on my Tableau Public, you see over here I have this option of server, but in my Tableau Public I do not get that. Even if I go to my file and I say save, I do not have an option of save button. It says save to Tableau Public or save to Tableau Public as. All right, so that's the reason you will have to create a public account in which you can save all your visualizations. This public account is absolutely free of cost. A word of caution, this is not a place where you can keep or where you should keep any sensitive data. It's absolutely public in nature. There's no security over there. It's primarily a platform, a kind of social media for Tableau kind of a thing, where anyone who knows your name or anyone who knows the name of that dashboard can go to that dashboard and access that dashboard, right? If you give them the download permission, they can go ahead and they can download a copy of your file as well. So that's the reason, do not keep any sensitive information on your Tableau public. Anything which is non-sensitive, mocked up data, which is not a real-time data, or something which is publicly available data, please use that data. Do not use any sensitive information, right? Um, and then you can create this account, and as I mentioned, it's absolutely free of cost and it's there for the lifetime. So you create it once, and every time whenever you're working, you can just keep on uploading the additional things that you're doing to this page. It will be more beneficial for you. Now, how can I create a Tableau public account? So let me, if I go over here and I save to Tableau public, it will ask me for a prompt where I may have to enter my credentials. And if you have your credentials, you can just enter it. But if you do not, we can just say create now, create one for free. And you have to give your basic details over here. Like, let's say I give my name, email, password, and confirm. And then you say, I have read the agreement. In case if you want to read it, please go ahead and read it. And then you can just click on this one, so for the legal process, and then you click on the create my profile. So once you do that, you will have a profile which will be listed on Tableau's official website. You can also sign up for the same account using this sign up account over here, sign up button. That's absolutely fine, it's your wish. But once you create it, you will have your profile over here, which looks something like this. Now, this is the author and this is a feature page. So all the featured authors who are very influential in Tableau's community space, or who have been publishing quite a lot of dashboards which are much more informative and intuitive, those people will be featured over here. But otherwise, let's say I want to see how does David's dashboards look like, I can just click on his name and I can find out more details about him, like what does he do, how many followers he has, or how many visits he has done. And I can see each of his dashboard, and we can click on each of them and we can see the details of the dashboards as well, right? So creating a dashboard, creating a Tableau public is very easy. It's just that you just have to fill up this small form, and that's it. So the first topic that we are going to talk about is data connections. What are the different type of data connections that Tableau allow you to do, and how you can establish a connection with this data sources. Later on, we are going to see about how you can work with the multiple tables. If there is more than one table, you can perform joins, methods like joins and at times unions as well. There's also a method called blending, but we may not touch base on that. But and in the latest version of Tableau, we have also seen something called as physical layer and logical layer of data connection. So we are also going to explore on that aspect as well. And then we will move to the next topic, which is called as pivoting your data. It helps you to transform your data from either from rows to columns or columns to rows using the pivot method. Now, what's the effective of this one? It's like many a times if your data is coming in a columnar format, it's very much common with the dates. Like if you have your dates in an individual row and you want to merge them into one column, we can use them. A simplest method is using a pivot method. Finally, we are going to see how you can clean your data in the most effective way. Like if there is any column rename you have to do, or you have to split some columns, or you may have to change the data types, and you may have to add aliases and many more things. From a cleaning your data perspective, we are going to see on all these aspects. So let's get into the Tableau tool and let's see how we can do each one of them. So first, let me move to here. So even before we start with let me close this one. So even before we establish or start with the joins, let's understand how you can connect to various data sources. Now whenever we are connecting to any of the Tableau's data source, you are given with the choice, either you can connect to a local file, which are your offline databases like Excel, CSVs, text files, JSON files, or any of your R or Python outputs, or any spatial files, PDF files. All these files can be connected using this mechanism over here, which is called as to a file, using this option over here. We also have an option where we can connect to any of the online data sources, which is your to a server, where Tableau gives you a wide variety of data source connections options over here. Like we have Google Sheets, we have Oracle database, we have MySQL, Hadoop, Hive, almost all the major data sources we have it over here. And the way you're going to, and in case if you do not have them over here, we can always use the ODBC or JDBC connections. We can also use the web data connections, where we can directly connect our Tableau dashboards to some of the web data connectors and scrape the data directly from those online websites. Now connect, and the third one over here is, let me just clean this one. All right, so first one over here is your to a file mechanism. The second one over here is to a server mechanism, and the third one is your save data sources. Now, save data sources is extremely helpful when you have to use the same data again and again in multiple projects. In those situations, like if we have taken some data, for example, an Excel file, and we have done a lot of cleaning process on that, and we have to use the same data source in some other files, but we do not want to do all that cleaning process. In that situation, what we do is we save that file from so that it gets saved in Tableau's engine, or more precisely in the folders of where all the data sources are saved, so that at a later point of time, whenever you have to re-access the same file in a new project, you can just go to your my data sources or my saved data sources, and you can get them. Right now, a little bit more about how you can connect to your local files is, you just have to click on any of the data source that you need. Let's say if you want to connect to my Microsoft Excel, you just have to click on Excel. If you have to click connect to text files, if it's a Excel file which is anything like Excel, XLSX, or any other extensions, we can just use the Microsoft Excel option. If it's a CSV extension, or it's a TXT extension or text file, then we will use the text file as a connection method. Now, how do I do this? I just have to click on this one, Microsoft Excel, and by default it's going to take you to its default folder, which is inside my Tableau repository. If I just expand this one over here, you will see in my PCs there is something called as my Tableau repository, and over there we have something called as data sources. Now this is a default behavior, however we can navigate to any of the folder where we have our data source, and we just have to, let's say I want to connect to this sample superstore, I just have to do a double click on this one, or I can click on this one and I can come here and I can click on the open button, and you will see the moment I do this, I will have a place where the data connection is established, and it will show all the worksheets which are already present over here in the form of the sheets, and it will say in case if you want to do a union, you can do a union as well. There's also a way where we can do the joins and all, but we'll see in next few minutes. Let's say if I have to connect to any of the databases, then we have an option where we can just click on this server connection type. Let's say in case I want to work with the Hadoop Hot and Hive, then I just have to click on Hadoop Hot and Hive, and you will get a window where you can enter your credentials and you can connect. Now there are two situations. One is there are few databases for which you do not need to add any install, or you do not have to install any additional drivers, for example, if I'm trying to connect to Oracle over here, you see I do not get any option over here, or I do not get any prompt to install any additional drivers. However, when I'm trying to connect to the same Hadoop Hive, I get an option over here, or I get a prompt over here which indicates download and install the drivers and then connect. Now, how can we download the drivers? You just have to click on this one and it will navigate to Tableau's official data website, where you have this drivers and uh, the format where you can find all these things. Now, let's say if I have to find from here what is the data source I have, what is the operating system, we have to give this credentials, and then it will tell you how you can install this. If oops, I'm sorry, and you can have it from Cloudera website and you can install it in the following process. If you still need any more steps, then you can always have more details over here, right? So that's the way in which you can install any drivers in Tableau's instances. Now, if it does not ask you for any of the drivers, then that's the best thing, then you don't have to worry at all. But otherwise, you just have to click over here and connect. And once you connect, now I have a connection already established over here. Let's say over this one. So I have already connected to MySQL database over here. And if you are connecting to any of the MySQL database or any other database, this is how it will look like. In case if your database is comprised of only one database, it's going to show it just show you that one single database. However, if you have more than one, then it's going to give you a list over here and say which is the database that you want to establish the connection. Now in my situation, I want to connect to my superstore US. So the moment I do that, it gives me a list of all the tables which are available and you have access to in this table view. Now we can have a preview of this data by just clicking on this small catalog kind of a symbol over here. And let's say if I click on this customers, I will get the data, this a preview of the data. It also tries to tell you, okay, there are 793 records. And if I have to do a join, I can directly drag this tables and drop it over here. Even if so, there might be a database or there might be a dashboard in which you may have to do analysis based only on a single table, or you may have to do analysis based on the multiple tables. Now if it's a single table, your job is very easy. You just have to drag and drop it, that particular table. Let's say I take this table orders and I just have to drop it over here and my connection will be established. Now all the tables that we have over here on the left hand side, they are just the tables which are being represented to you, or they are just being shown to you. Need not necessary that you are accessing all these files, so they are not going to increase or decrease the size of your dashboard or your file. Only if you add anything into this window over here where you can establish all the data connections, only and only in those situations you will have the data inside the Tableau's engine, and when you save it, it will be part of your Tableau's workbook, right? Now in case if you are in a need of the entire table, we can just drag and drop it over here. But let's say if I want a part of that table, I do not want complete table, but I just need a part of it. And when I say part of it, it can be a vertical chop of your data, or you can just chop off your data in the horizontal fashion as well. I'm so sorry, yeah, in the horizontal or in the vertical fashion. What do I mean by that? It's like if I do not want to have any columns, we can remove them. Or if we have to restrict our data, let's say you have 10 years of data or 20 years of data in your database, but you just want to do analysis of the last 2 years, right? In those situations, your custom SQL is the most effective way where you can do that. So I just have to drag my custom SQL over here, and here I can write a query of my choice where I can restrict the uh, where I can restrict the columns or the rows as per my choice. Now, how does this comply? Like, let's say you have various data sources, Hadoop, SQL, Oracle, Google Sheets, and many other things over there, or Spark and Splunk and many things. So, how will Tableau understand which of the rules you should be following? So, the very simple answer is it depends on which connection are you leveraging. Let's say if I am using MySQL, then I will have to adhere to the rules and regulations or the policies of or the syntaxes of MySQL. On the other hand, if I'm trying to leverage a connection with Oracle, then I will have to take care, or I will have to give the syntax which are in compliance with the Oracle, that particular database. Now, we also can do union in case if we have more than one table where we have to do the joins. Let's see how we can do all these things in a much more detailed fashion. Now, Tableau has recently come up with a new mechanism in its latest version, which is Tableau's 2020.2, where you get an option called as physical layer and a logical layer. Until now, there was only one type of connection which was called as physical layer, and that was your default behavior. So for example, let's say I have this table over here. So I can open this one over here by clicking on this one and say open, and you see I have a small window over here. So this window is called as your physical layer, and this is how your physical or the traditional database joins has been happening in Tableau until now. Now, if I have to do any join with this one, let's say to this orders table, I want to add the customer data. So what I can do is I can just drag this customers and I can drop it over here, and I'll have a join over here. For this joins, we will have to define what is the kind of join that we need to uh, leverage. By default, Tableau is going to pick up the inner join. Inner join, so there are four types of joins. I hope you know it. If you don't, then if you know, you can skip this part, but if you don't, you can continue listening to this one. Is there are four types of joins. The first one is inner join, where Tableau is, or for that matter, the joins are applicable in almost all the databases in the uniform manner. So if you have more than one table, let's say, so whenever you have two tables when you are performing a join, so the table which is on your left hand side is called as left, and the one on your right is called as right table. Instead of using the names of the table, we will call out with their position. And the way it works is, so whenever you are trying to connect any tables, it is going to ask you on which column do you want to perform this join mechanism. Now, one thing that you have to remember is you have to use the unique column which will create a join on one-on-one basis. Now, what happens if you have values which are not unique? Let's say I'm using a city as a column to join. So in those situations, if the values are multiple, your data gets replicated or duplicated because it has to do one-on-one join for each of them. So it's always advised that you use only the unique columns or the value columns which has the unique values in it. Now, customer ID is one of those which will have the unique values in it. So this is how you perform a, like, establish a join connection. But if you have to understand what kind of join you will have to do, then we will have to understand this each of the diagram. What does it mean? The first one is the inner join, and if you see at the image very clearly, or the icon which indicates the inner join, it has two tables. The tables are represented here in a circular manner, and it has the shaded area in the center which indicates only this part of the data is going to be taken as your output, right? So this part over here will be taken as the output. Anything which is not in common will be excluded. On the other hand, we also have something called as left join. So what left join does is it will pick up all the data which is available in your left join. Now, any information which is matching to your left will be picked up from your right side table, and hence you see the left table is completely colored and the right join table is having only the shaded portion colored. Right, the complementary of this one is your right join. Now you might be wondering, okay, if the when I say complementary, it means it works in the exact same behavior. The only thing is you will have the column or table swap. In this situation, your right table will be given more preference and all the values from your right table will be picked up first, and the matching values from your left table will be picked up. Now there are instances where you can just, if you have two tables, then your left and right you can just swap them. Like I can change the position of orders to customers and customers to orders, and it works absolutely fine. And I can, instead of changing the join type, I can just change the position of tables and it works absolutely fine. But if you have more than two tables, or where you have some complex schema or a complex diagram which you are trying to establish, in those situations your left and right join can be helpful, or there you cannot swap the tables so easily. So in those situations we can leverage this benefit of left or right join. Now in all these three cases, what was the most common thing? The most common thing was, in all these three tables there is a certain level of data loss. Which means, if let's say I have a table on my left hand side which is having, let's say, 100 records, unique records, and on my right hand side I have, let's say, 80 records, out of which I have 50 records which are only overlapping with my left table. Right, so my final output is going to be this 100 records from here, and the output from this table is going to be only 50 records. Why? Because I have specified a left join. Right, so I am in a loss of 30 records over here. Why? For the very reason, the data, there was no matching records in my left table. Right, now in this kind of situations, let's say if that's also a valid situation, or this kind of table join is also valid. However, let's say you have a situation where you do not want to lose this kind of data, then we will adhere, or we will leverage a mechanism which is called as full outer join. In this, both the tables will be given equal amount of importance. Both the tables will be taken into consideration when they are trying to pick up the information. And what it does is, so let's say I have two tables over here, and my first table over here is having some records, and the second table I'm having some records over here. Now it's going to match the records and it's going to pull the data. Let's say the third record over here does not have any matching values, so what it does is it will give something called as nulls over here. Right, similarly for any table which is on the right hand side, and if that doesn't have any um, complementary or matching values on the left side, it is going to add some values which are called as nulls. Right, so that's one of the problem we have to deal with whenever we are doing any type of joins, regardless of just not just the full auto join, but it applies in your left join as well, your right join as well, and your full auto join as well. Now the next thing that we have to understand over here is, let's say now you might be thinking, okay, we have these four different joins, but which is the most common, or which is the most correct join? And the answer is, there's nothing that there's incorrect joins and there's correct joins. All of these four joins are correct and valid. The only thing or the only factor which allows us to decide which one of the join that we have to leverage is we have to ask ourselves what is the condition or what is the business problem that I'm trying to solve. Based on this question, you will take or you will choose the data type in the appropriate fashion. If let's say your business requirement or your dashboard requirement needs all the data from both the tables, we will leverage the full outer join. But however you say I need only and only the data which is matching in both the tables, then we will leverage the inner join and subsequently the left or right outer join, right? So that's about how you can create the joins. Now whenever we create joins, it's like we are trying to add additional columns to our existing table, right? Like you have four columns, and when I do a join from this new table, let's say there are two new columns, so now I will have a join where I'll have 1 2 3 4 5 6 columns, right? So the length of my table will never increase if I'm performing a join. It's only my width of the table is going to be increased, or I will have additional attributes in case if I'm using a join. What's the next thing that we have? The next we have is unions. Now, what do you mean by unions? So in unions, you do not perform this kind of joins. A common um, requirement that we need when we are doing union is all of the columns should be same in your union. Let's say I have this table over here, so and if I have column 1 2 3 4 and something like this, 1 2 3 4 5, so all of these columns should be same in both the tables, including its name of the column and the data and its uh, order as well. So both the tables should have the same headers and in the same order. What we do is in those situations we append data one below the other, so that it's like we are stacking up the data one above the other. Where is this useful? Many a times what happens is your database may have information which is stored, for example, for one location in one place, the another location in another, but all of them have the same data. Let's say I'm working for a company which is situated in more than one country, and each of my country's data is stored in one of the tables, and I want to do a join to see a worldwide sales that are happening in my company. I can just take all those columns and stack one above them. The second very common useful situation is related to the dates. Many a times what happens is uh, you may find few tables, like let's say Q1 data is stored in one table, Q2 data is stored in another, Q3 is stored in another table, might be just for the optimization purpose where they want to keep the table short. So in those situations we cannot perform joins because both the side tables will have the same column names and the same values within it. Now I cannot join customer A with customer B as a join. There's no logical connection. If I perform any join on these two things, either I will have lots of nulls or I will have no data in it. So the more logical situation comes is, or the more logical solution over here is, we append the data so that customer 1 and below him will be the customer 2 and so on, right? So how you can do a join? So instead of performing this kind of mechanism over here, I will have to let Tableau know that I want to perform a union, for which I will have to drag this union option over here, right? And whenever I get this union option, in this place Tableau will ask me, you see there's a slight difference between the join interface versus the union interface. So in this union interface I will have to drag the tables which will have the data of the same column type. Now here I have four tables. I will just show you a preview of it. So if you see here, I have the columns as category, city, country, customer ID, and so on. And the region over here is only East, right? Similarly, if I go to the South data over here and I see, again, my data will be starting over here from category, city, country, and so on. And if I traverse, I will see here the region as south. So all the rows are same except for my data which is differing in the region format. So region 1, region 2. In this cases, I can just drag my orders from east, orders from south, orders from west, and you see I have a union connection established over here. And I can click on OK, and I can have a union and a join combined together as well. So over here, the mechanism is working on union, but this union table is again connected to my master table in a join format. So you can have this blended um, usage of joins and unions as well. It totally depends on how we are leveraging our union conditions or your join conditions. I'm just going to remove it from here for the sake of discussion so that I can show you something more in the later instance. So this is all about your physical layer, and if you understand the logical layer is somewhat same, not exactly same, but somewhat same. Um, so this is all about your physical layer. Now a small hint that shows over here is this is the order tables, but it is not as same, or it's not a simple orders table. Here you have a small prefix which indicates, okay, there is some union which is happening inside this physical layer. So if you want, you can see that by just clicking on the open button, or you can at a later point of time, if you want to access, you can see that. Now what is a logical layer? So logical layer is, now I can establish a connection with this one. Let's say I have to establish a connection with people. So what I can do is I can just drag and drop it over here. Now earlier, if you have seen, it's just taking few moments to connect. So I will have to give on what basis is my data being connected. So over here it just auto picked up region, so I'm just going to leave it. So over here you see there is no join condition as such. It's not merging the data together, it's just creating a logical connection between these two things, so that whenever at a later instance, if I'm working on, let's say, order data, and I want a reference from my people's data to see how many people are there, I can just call that into Tableau's mechanism, and how it will connect between these two things is based on that column which we just specified. A common example I can give over here is, let's say you go to a store and you are buying some products. Let's say a table A is storing all the information of your demographics, like your name, phone number, and everything, and the other table will have, let's say, what all items that you have bought on the different instances. Now if I perform a join, all this information will be merged together and a single table will be called into Tableau, and Tableau is not going to differentiate which is the table or which are the two tables separately. Now Tableau will consider both these tables as a single format. However, in the second mechanism, if we are using a relationship kind of a mechanism, this mechanism which is over here, which is the logical connection, Tableau is still going to keep these two tables separately unless you say that, hey, I want some reference from the second table. It's not going to call that table or the data into your visualization. And whenever it's calling, it will call based on the ID, or let's say here in this case, I have the ID or your phone number as a unique identifier. So it will use the phone number to match the records and get the data. All right. So that's a very brief understanding of unions and joins and the logical things. Now we can also perform the relationships using a combination of unions and joins as well, in the same way the way we did for our physical connection. Now if I drop a union over here, I'll again be asked for what should be your table values, and I'll just add this. And if I say okay, and here it asks me for what it should be. So I'm establishing a connection based on the customer ID and customer ID over here. It's just taking few moments to connect. and if I close it, you see I have a union connection established. Now you see over here there's again a new symbol which is given over here. So if there is no any if there is no uh, joins or unions that are happening inside this physical layer, you will get a plain table which looks like this. If you are having any joins, it looks something like this, and if you have any unions, it will give you this kind of a indication saying that hey, it's not the original table, but there's some algorithm or there's some changes that has been made, and you can have or you can consider that when you are actually working on your visualization. Now we can also establish a connection between this second table and the third table. Let's see if I can use something else. I can get the customers over here, and I can have one more join to this one, and we can keep increasing this join mechanism. I don't think I have anything common over here, so I'll just remove this one, and I'll try to see something else. Let's say I get the orders table only, or the dictionary table over here, and I assume there's some connection. So let's say no, I don't have it here either, but okay, let's not use this one either, and I'll use the orders over here, which is not the correct thing, like because we already have the orders, we don't need it here. But to showcase that we can have the multiple chain of interconnection, I just wanted to show you this one over here. Now if I just close this or remove this for our for our discussion purpose, so this is all about how you can do your joins and how you can do your um, connections. Like once you connect, you can do these joins and unions. Now let's see how you can perform the pivoting of your data. So what happens is, as I said you earlier, like there will be few instances where your data may not populate or that will not flow in the way that you want. Like for example, I have some columns over here, let's say my product name, sales and quantities, which are listed in a vertical fashion, but I do not want them in a vertical. And if I want to have them in a horizontal fashion, the very simplest way what we can do is we can select those columns and we can say pivot on it, right? Now let's say I have these columns over here, sales, quantity, discounts and profits. What I want to, instead of having them as four different columns, I want them as one single column. I want to name it as numeric column for that matter, let's say. So what I will do is I can just click on this columns by holding the control key. I'm sorry, and I can just do a right click over here and I can select the pivot option. I guess it's not possible because of this one, or let me use this option over here. And over here you can see the option of pivots, right? All right, so let's see about uh, all right, now let's move to the next topic, which is pivoting your data. And for pivoting our data, I'm going to switch to the next data source, which is our Excel data source, which is sample superstore, where I have the data, the same data, but in a little bit different fashion. So let's say I have the sample superstore where I have the, if you see over here, it says as Microsoft Excel and not the Oracle database. So in this Excel, let's say I have few columns over here in which I have to perform a join, or I have to pivot, I'm sorry, not perform a join, I have to pivot this data, where let's say I want to convert these columns into a row kind of a information, right? So what we can do is we can just use a control button over here, and we can click on these columns, and we can just do a right click. Oops, that's my bad. So I just have to be more careful when I'm selecting this, and I have to select, I have to do a right click, and I will use a option of pivot, right? So what happens as soon as I do a pivot, these columns will vanish off, and I will get two new columns which says pivot field names and pivot field values. So imagine if you have situation like date 1, date 2, date 3, date 4, and so on, and you just pivot that whole information. So this becomes your date 1, let's say this is Jan 1st, Jan 2nd, Jan 3rd, or week 1, week 2, week 3. You'll have all those columns over here in the form of a rows, and the values against it over here in your vertical fashion, right? So we can use, or we can leverage this mechanism whenever we have to perform any pivoting, or when you have to convert or transform your data from your vertical fashion to the horizontal one, right? Now, the last piece on this segment is about cleaning your data by using this preview window. So we have seen about the first pane over here, which was all about your connections, where you establish the connections with various databases. The second window over here is about how you can create the joins, or how you can create your data, right? And the third option over here is your preview window, where you can clean your data, where you can have a look at the data which is being imported. Now let's say in my situation over here, I have just one table, but if I have more than one table, I will have a preview over here. For instances, this is very helpful when you are not sure about how does your data look like in your databases. In those situations, I can just drag the table, and I can have a preview over here to understand what are the different columns I have, what is the column type it is, how many values it is taking, and so on and so forth. It's also useful when we are working on some joins or unions conditions. Let's say I'm trying to create a join, and I'm not sure if the output of that join is going to be a valid output or not. I can create a join, and obviously during that join, if I'm writing a custom SQL, I have a preview option. But if I don't write a custom SQL, and I'm just trying to do a join based on the physical out layer, then I can see over here how the join is happening, right? If the join is incorrect, you will not get any data output over here. So let's assume you did a correct join, and you are having the output now. So we will see how you can clean your data from this page. Now, first thing is, we can see over here what is the data type of each of your column. Now, if it's a numerical column, it comes with this hash symbol. If it's a string, it comes with the ABC as a prefix or icon. If it's a date related column, it comes in a calendar kind of a symbol, small calendar over here. If it has a time also, then a small clock is also added over in that icon. I can show you by changing this one from date to date and time. And you see over here, it shows as date and time with a small date icon, or I'm sorry, the clock icon over here. And there's also some beautiful thing in Tableau which is called as geographical columns, or the columns which has geographical importance. These columns can be used to create maps in Tableau in later stages. Now, by default, Tableau will look at the name of the column, and it will see if it has any geographical importance to it. Let's say like countries, states, cities, provinces, districts, and so on and so forth. If it has to do something with the geography, then it is going to assign that geographical symbol. If it doesn't, then we can also go ahead and give a geographical importance to that column by just clicking on that data type and going to the geographical role. and selecting whatever the data type or whatever the type of the geographical association that column has. We can select that type, and it will give that latitude and longitude coordinates to that values. Now how Tableau does that? Tableau will pick up this name, Kentucky, let's say, for this example, and it's going to find out what are its latitude and longitude with the help of a map tool which is called as OpenStreetMaps, and it's going to auto assign them. In case if Tableau fails to do that, there's always a way where we can manually assign those values. Even if there is a kind of ambiguity or if Tableau has done it incorrectly, we have a way where we can correct it, so we don't have to worry much about that. Right. And so this is how the way I showed you, right? Over here you can change the data type. So let's say at any point of time your numbers may have come in a textual format. That's a very common problem. Or might be your date has come in a form of a string or in a form of a number. In those cases we can just click on this data type, and we can change it to the type of our required data type. Let's say I have a data type which is date. Instead of ABC, I need it in a numerical format. I can just click on this number hole and my numbers will be given over there. Now in case if I want this column, for this matter I want to split this column so that I want to see this year. If you see, if I read this column properly, the first one says okay, the country of origin. The second one is the year in which this order or the product was manufactured, or this order ID order has been taken, and the final is the unique order number. So what I can do is I can split this column by just doing a click on this one over this drop down, where we have this various options of cleaning the data. Number one can be uh, renaming this column in case I want to rename. But for now I'm looking for something called a split or custom split. I can use either of them. We can use split, directly splits the data. Custom split is where I have a freedom where I can tell Tableau on what basis it should split. Now the allowable values over here are, you can see over here, it can be like hyphen, comma, semicolon, colon, and many other things. You can define what kind of identifier it is, and you can tell here how many splits it should happen. Should it take only the first identifier? Let's say I'm having hyphen here 2 times, so it asks me over here split off on the first one or on the second one, or I want it on the both the things. We can select all those options from here. Is it the first split you want, or on the last one, or all the values should be split? So let me say over here I want it on the hyphen, and I wanted the split on your all the values over here, all the splits that we have, all the split identifiers. And if I click on OK, you see my now order ID is being um, segregated into 3 unique columns. The original column remains intact, and you have the 3 new columns over here: order ID 1, order ID 2, and order ID 3. Now I can simply do a right click on this one, and I can just rename it, or I can just do a double click. It's up to you. And I can give over here the name as year, and here I can give it as order number, and so on. We can rename them. Let's say this, now if you see, this column is coming as a text column, but we know it's not a text, but it's a numerical column. So what we can do is we can click on this data type and we can convert it to the number whole. Now in this situation it doesn't make sense if I convert this to a number, because if I have a numerical column, it will use the mathematical operations on it whenever it's trying to showcase on the screen or in your visualization. It's going to add up all these values, which doesn't make sense very much, right? So we can retain it in the ABC format or in your string format, so that Tableau do not add those values and showcase them as an independent or the individual values, right? Now a small thing to notice over here is you will see there's a small equal to symbol which is appearing against this new columns that are being generated. So whenever we generate any new column in Tableau, we call them as calculated fields, right? And all the calculated fields will have a prefix of the equal to symbol, indicating these columns are created within the Tableau's environment and they are not flown from the database directly. Now, one more thing that I would like to emphasize is, like, whenever you are trying to work on any of the tables or any of the data or databases, do not worry, you can work with at most level of confidence that your data in your database is not going to change. Now whenever I create this kind of a split kind of a thing, it's just within this Tableau's environment. What do I mean by this one? If we have, let's assume this is my database and this is my Tableau's data engine. So all the information which we are working is going to, or all the changes that we are making are going to happen within this engine itself. Tableau do not have the power or do not have the capability to write back the information. It's just one way. You take the data from database, you do all the changes and you keep it over here. That's the reason we have the save data sources, right? In case if I do any changes to my data and I want to reuse it at a later point of time, I will use, or I will save it as a save data source, which is a kind of a replica of your original database, and then I will leverage that save data source for any other projects. But we cannot write it back into our database. All right, so that's something we may have to remember when we are working on the joins, when we are cleaning the data, or when we are changing any of the data types and you are skeptical, will that affect my data? You can rest assured that nothing is going to change in your database level, right? Even if you just have a read access, it's absolutely fine. You can just get the data and you can modify the data in Tableau's engine. All right, so that brings us to the end of this session. I hope you guys understood what all we can do on this page. So the first one was where we can do the connections. The second page over here is your joins page, and after that you have to navigate by clicking on the sheet one into this environment where you can create the various charts and all your dashboards and visualization. So a quick recap of what we have done is, let's have a quick recap. So first we started with data connections. We saw that there are three types of data connections. It can be either a local connection, or we can connect to the data servers, and the data servers range, we have a wide variety of range. It can be either SQL, Oracle, all the leading databases, you will find it over there. In case if you do not, we can always use the ODBCs and JDBC connections as well. And then we moved to something called as joins, a place where we got the data from our tables and we tried to create the joins, unions. Here we also had the logical layer, the physical layer as well. Physical layer is the traditional Tableau's legacy system, where you can connect joins, and whenever you are creating a join using a physical layer, Tableau merges those tables into one single table, so that in your future references of that table in your visualization, this table is going to behave as a single table. However, if we are using a logical table, it's just going to establish a connection, but it's going to call those tables as two separate tables. And whenever you need the second table or reference, it's just going to call it, right? So that's a very small difference between your logical and a physical layer. Then we also saw about the pivoting table, how you can pivot the data. Pivoting table is where you convert your columnar information into the row level information for the more or the better data understanding. Finally, we saw how you can clean your data in the preview pane. Cleaning your data in your preview pane is not 100% necessary that you should do only in the preview pane itself. Even if you miss on some of the instances, like let's say you forgot to split the column or you forgot to change the data type of the column, we can do them at the later instances as well. But all the other three things, like let's say pivoting your data or working with your joins, if you do not do it correctly in the first instance and you start working on the visualization, you come back and you do any changes over here, high chances your data structure may change, and thus your calculations may take a toll. Not necessarily 100%, but most of the times it does take a toll on your calculations if you are just increasing or you are changing the size of the data in its width or in its length in a very different fashion from what it is in the current situation. So I have few charts planned up which start from the very basic charts which are like text tables, and then we will move into the bars and line charts, and gradually we will be seeing some of the advanced charts like scatter plot and donut. So as you move ahead in this session, you will see the complexity of the charts will be increasing. All right. So yeah, with that note, even before we start with the text tables, or even before we start with the charts, let's understand like why is it really so important to um, select a particular chart and make it the way it looks like. So whenever you're creating any data visualization, what's your prime focus? Your prime focus should be any end user who is taking this report to understand the business should understand this report in a much more clear manner. There should be no ambiguity in it. If there is any confusion, then that may lead to a serious problems. There are many business cases uh, or use cases on some of the portals where you can see how the misinterpretation of data has cost a company a ton of money, right? So I'm not going to get into that, but yeah, that's a serious problem now. So to avoid those kind of situations, we have to create visualizations which are correct and which are from a data standpoint or from the data principles, they are correct in nature. Now one of the biggest problem is you have to choose a right chart. Whenever you're creating any visualization, you have to choose a right chart. Now given if you can see on my screen, like there are nearly 10 to 12 charts, and most of them have a similar number of categorical or the numerical column requirement. Now, how are you going to select the best chart? Can I make all the charts look like a bar, or can I make all the charts look like a pie? It's the answer is not. So we have to take a cautious call between these things. Now, and even after you take or you make that chart, it's much more important that you keep that chart clean, neat, and precise. Like you're not going to bombard the end user with a lot of information. At the same time, we cannot cut short all the things which are there on the chart. So we have to strike that balance, and we have to understand how much is too much, right? So let me give you one example. How does it look like if we bombard our end users with a lot of information, and how can we ignore this kind of situations? Now if so, this is a example I have picked up from the official Delhi Metro rail systems transport map, and I think this is pretty much similar to um, many other maps that you will find on the metro trains for any other busy rail routes that you will have, right? And look at this chart, means how easy is it for you? Like in the first glance you are going to feel, oh my god, there's a lot of information over here. You will not have that kind of a confidence that I can start from a journey point and I can traverse myself to understand from where should I lead to reach to my destination. If there are any transit points, if there is any like do that route exist at all. those kind of information, if I have to traverse from this, I think it's bit of a tougher thing. Now, speaking about like what's happening in this chart, like when I'm looking at a rail route, I do not think it's anywhere necessary for me to understand if there is any water body which is flowing, or if this is a city outline. um, yeah, that's important from the geographical perspective, but from a perspective of my journey, at least to understand from where should I start and where should I end, I do not think that's much of the important one. Now, let's look at the revamped version of the same thing, Delhi's mass rapid transport system. This one is from the January 2017, which they have published, I believe, on 31st of March 2017. Now let's look at the later version, which is a much more revamped and a clean and precise. Now it's the same thing. It's the same Delhi Metro's map, but now you see how does this map look like. Even here you have the water body which I mentioned, but in a much more symmetrical format. But now looking at this chart, I feel a bit confident. Okay, I don't know, but I can still traverse my destination. Like, let's say if I have to start from this point over here, I can traverse myself and I can see how many stations I have to cross. If there is any transit I may have to take to go to any other place, or I can just use the same one and I can reach my destination, right? So it boosts up the moral value of your end user. It helps in increasing the engage rate if you keep your charts precise, if you keep them clean, if you make them look more tidy. And I think that's one of the reason why companies adhere, or they insist on having the branding standards, that you should have these branding standards and you create charts which look according to them, right? So we are going to understand few of the branding standards, why is it so essential, also in the later part of the sessions. But for now, so that's to just this is just to give you an idea and a food for your thought, that okay, whenever you're creating some visualizations, let's keep a thought in our mind that we have to make it look a little bit more clear and precise. All right. With that note, let's get into our Tableau tool. And even before I start with our visualization and I explain you how to create a chart and everything, let me give you understanding on the few of the basic things which you may have to understand before we start with the process of chart creation. So first and foremost thing that you may have to understand over here is this part over here on the left hand side, which has this two partitions. The first one is called as your dimension. The first one is called your dimension, and the second one is called your measures. Now, if you are using any version which is after 2020.1, so 2020.1 was released in Jan. 2020.2 was released in March of 2020. Now any version, if you are using which is equal or higher than 2020.2, you are not going to find these names. However, you are still going to find this thin line over here, which is a bifurcation between the dimensions and measures. So Tableau had a tradition of having these names, dimensions and measures since the inception of Tableau. However, in the recent edition, for some reason, they felt, okay, this is not needed much longer. So they have removed it. However, the functionalities of dimension and measures remains the same. The nature, the behavior of these two things remains the same. Now, what do you mean by dimension and measures? So your dimensions are any non-numerical data, right? It's any non-numerical data, and all of your measures are purely numerical numbers. So it can be either a percentage, it can be an integer, it can be a floating number. All the things are going to be covered inside your measure columns. Now all your non-numeric numbers, like for example, if it's a text column, or if it's a binary column, like which comes as true or false, or if it's a column like location, which is indicated by the globe symbol, or even if I have to say, like, if it's a binnings, uh, you will have something called as bins, hierarchies, groups, which will be represented as a paperclip symbol, and all these things. So anything which is non-numerical in nature is your dimensions, right? So this will be this is going to be a very important thing when you are going to decide which kind of chart you have to select when you are creating any visualizations. Now, what you're going to do, you're so for now I'm going to ignore this space shelf, I'm going to ignore this filter shelf. We have a dedicated sessions for that. So the next one is your mark shelf. Now, what is a mark shelf? Let's understand for now in the simplest fashion. This is as good as a makeup kit, right? It's a makeup kit for your Tableau charts. So what does it do? It helps you to change the colors. It can also help you to increase or decrease the size of your visualization. In case if you want to add any texture information, it can be the actual values or any supporting information. You can use this text box. You can also add some additional information using a tool tab, and you can add details to it using the detail shelf. There's one more card over here, which is kind of a joker card, which will appear only in the certain situations. We will see when we are actually dealing with those kind of charts. This mark shelf will automatically pop up. Then you have your column shelf and row shelf. Whenever you're creating any visualization, the output is going to come over here in this white space. But to make your visualization look over here visible, you will have to insert the values in your either of your row shelf or your column shelf, right? How it works again, we are going to see in few moments. Now, this is all from your pre-existing shelves, what we call them. So this is a column shelf, row shelf, mark shelf, filter shelf, page shelf, and your data pane. Now, one beautiful thing over here is you have something called as show me. On the right hand side top corner, if you see, there's something called as show me. If you click on this one, a window is going to pop down. Now I can just detach it from over here and I can get it into the center for our discussion purpose. Now show me has a inbuilt template which helps you to understand, okay, if I have to create a text table, what's the requirement. If you see over here at the bottom of the screen, you will get the requirements, like how many dimensions should be there and how many measures should be there. Now for example, if I'm trying to create a tree map, I need at least one dimension and at least of one measure. Why am I saying it at least? Because that's not the hard code values or hard code requirement. Things can be changed or things can be altered, but there's something as a minimum requirement, right? So we will have to understand these things as well, what is a minimum requirement and what is the optimal way in which you are going to create this chart. Now, I think that's enough for now to at least kickstart the text table or any of the charts that we are going to build. But there's lots of things that we have to still explore. But I am going to take it in small chunks so that you do not get overloaded with the information. So for now, let's get started with the text tables, how we can create it. Now, first of all, okay, let me rename this worksheet from here. Either I can just do a double click, or from this drop down over here, I can click on the edit title and we can rename it. Now I can name it. So this is the dynamic way where if I change any value here at the bottom of the screen, this can change as well. But for now, I can change it here, or let me show it from the bottom of the screen. How does it look like? So let me rename it. Oops, I did something wrong, my bad. Let me rename it, and here I can just write it as text table. and you see the value over here got changed as well. Now, if you have to understand about text tables, why is it important? From the reporting perspective or from the data visualization perspective, it's of a lesser significance. However, there will be few instances where we do give the text tables to the end users so that they can download the raw information which is sitting behind the scenes. That is still possible through any of the charts that you are displaying. You can click on that chart and you can get that information. However, there will be few clients who need it as a separate tab, or let's say we may have to make it as a user friendly. In those situations, we are going to give this as an additional chart. Its creation of this chart is very simple. You just have to drag the number of dimensions that you need and the number of measures that you need, and that's it, right? But small difference when you are actually dragging the measures. Now, whenever I'm trying to drag any of my charts, let me use this song data. So if I'm trying to add some column like this, which is having a limited value, you see I had only 0 through 11, so I it was pretty simple. But let's say I'm trying to add something which is quite a heavy thing, which has like 6523 unique most values. In those situation, Tableau is going to give you a prompt and ask, hey, there's a lots of things that you are trying to incorporate onto your visualization space. Is it something that you really need to? And if you feel okay, no, I need to filter them, then you can go for all of this rest of the options, or in case if you change your mind, you can just select do not add. But however, if you feel okay, I need all those values and I may have to continue anyways, then you can just click on add all members, and you will see all the values will be popped up on your screen. Now, um, it doesn't matter how many times these numbers are being repeated or how many times these values are being repeated in your database. It's going to give it only once on your screen. Now, how can I prove this to you? For that, let me call from the measures something called as number of records. I just have to drag it and put it into the text table so that I get the number of values over here, right? Now you see this the second line, which is two grand de la bachata, is twice in our database. Similarly, if I sort it from highest to lowest, there are few values like which is like electricity, which is 16 times in our database, right? So like this. But however, in the text table, it's going to be represented only once. Now that's the beauty of your text table. Now I can keep on adding as many values as I want. It's again asking me because it's more than 1,000. So I'll still say yes, and we can keep adding them. Now there's a mechanism where you can actually show this value, like let's say Spotify singles, which is there for all these columns, where you can show them only once. Or there's also a way where you can make it repetitive the way you get it done in the pivot charts. Like if you have anything, you can, in pivots it's a bit easy where you just do a right click and say repeat all items in the chart. But here there's a small trick where you may have to add a small calculation for it, and it can be done, right? I'm not going to get there for now. But however, if I have to add some more numerical values, what I will have to do is, instead of dragging and dropping them over here in the column shelf, I may have to add them in the automatic, in the text table, or in the text shelf. um, Rather than dragging and dropping, the much more efficient way over here is we can do a double click. If we do a double click, the value is going to come and fall into your text table. Now if you see here, I had the number of records, and I also have the song popularity now. um, Now if you have noticed, there was a transition that happened on your screen, a very clean transition. So whenever you are adding more than one measure, what Tableau does is Tableau automatically adds this measure name over here, and the measure names in the filter shelf, and the measure values over here. And within this measure shelf, it's going to create a new shelf over here, in which it's going to add these values over here one by one. Now let's say if I add one more value to this one, let's say I want to add a tempo. So if I do a double click, I got the tempo column over here, but it was actually included over here, right? So that's the beauty. Like, you can keep adding them as many as you want. Now what do you mean by measure values and measure names? If you're feeling something like that, don't get confused. It's something, Tableau's inbuilt functionality. I'll be giving you more details on that as well, right? But for now I can just erase this one. And let's say if I want to add something more to this one, I can just drag and drop it now the next columns over here, and I can keep getting them on my screen. All right, so that's how you create your simple text tables. All right, I hope you guys are able to follow with me until now. If not, you can just go back and you can see this session on text tables, and you can also keep doing it. So wherever you feel okay, I think after every chart you can take a pause, you can try to recreate, and if you're not able to understand, you just keep you just see, rewind and see how did I do that. Okay, now the second chart that we have to do over here is the bar chart, right? So this time, instead of renaming it over here, I'm going to rename something over here, for which I'm going to do a right click and say edit title, and here I'm going to name it as bar chart. Oops. Now if I say okay, you see the name got changed over here. However, that it's not renamed over here. This is the name of the sheet and this is the sheet title. What's the difference? The sheet name is going to be part of your, as a reference for you at a later point of time whenever you are trying to access the sheets. This one, sheet title, is going to be there on your visualization. Your end user's reference is this one. So this one is for you and this one is for your users. So let me rename this one as well. It's bar chart, right? Now creating a bar chart again is a very simple thing, and bar charts are one of the most commonly used charts, I feel, in all the dashboards. uh, Most of the dashboards that you pick up, you will find at least one bar chart or one line chart in it. um, it's very easy to read, it's very easy to interpret. You do not need any statistical background to understand what do you mean by the bar charts, right? It's very intuitive in nature. So and it justifies almost all the situations. Like if you have any place where you have to do some comparisons or you want to showcase um the, how the uh, difference is between the two values, it's very easy to show using a bar chart, and I think that's the reason why it's so heavily used in the data visualization space for most of the business related requirements. Most of the times, if you are dealing with any competitive or any social media platforms where you have to make it look jazzy and funky, they may not include it. But from a standard business driven situations, bar charts are the one which are more preferred one, right? Let's see how I can do it now the same way. Earlier what I did over here was, I added the dimensions in my row shelf. Similarly, I'm still going to add my dimensions in my row shelf. But this time, instead of adding my measures into the text table, I'm going to drag and drop it into the column shelf over here. And you see the magic? The bar chart is already ready for us. Now that's the beauty of Tableau. What Tableau does is it's going to understand the placement of the pills. We call this blue and green color things as pills. So Tableau understands the placement of the pills, and even the type of the pills that you have been selecting. Now you will notice in our later the next chart type, that what happens if I put a date related pill. Now that's the beauty. Like if you're placing it over here, it gives you as a bar chart. If I place the same thing into the labels, I'm going to get it as a number thing. All right. Now there are lots of things that you can do using a bar chart. Number one is, like, you can sort them. If you are not comfortable with the orientation of this one, you can simply swap this, like the keys goes into the columns and number of records comes over here. You can manually move them, or you have a shortcut over here which you can just click. Ta-da, you have it ready, right? You can also add the labels and so many other things, but for now I will just try to give you a few things. Like, number one is, like, it's preferred that you sort your bar values most of the times in the highest to lowest value, so that it gives you a readily comparison. Now I do not have to break my head to find out which one is the highest or which one is the lowest, right? So for that, what we can do is, there are again multiple ways of sorting, but the simplest one is by just clicking on this sort button over here, which will give you the data in the descending format. Now if I click on this one, you see my values are sorted from highest through lowest. We can also add colors to this one. If we add values from the dimension, we get the discrete colors, which is like one for each one. I'll show you how does it look like. It looks something like this. But if we want a continuous gradient, then we can use our measures, and I can put the same thing in again in the same color shelf, and you see I got a color gradient over here. Now I can also change the color of this one by just doing a double click over here, and I can select any other colors of my choice, and I can just say apply and OK. You see how beautiful it looks like? Yeah. So this is how you are going to, and I just enable the row label, I'm sorry, the labels for each one of them, so that I don't even have to break my head looking at, okay, how much is the delta kind of a thing. Now this is how you are going to make your charts make look more and more intuitive. By default, Tableau will give you a chart like something like this. Now I was showing you. So yeah, by default you got a chart which looks like this versus a chart which looks like this, right? There's a difference. So this is how we are going to do a lot of formatting and make it look more beautiful, right? Now I can just clear the screen by just clicking on this one, and we are going to have again a plain slate. Now the third chart that we are going to see is the line chart. For that, let me do a right click and click on rename, and I'm going to select the line chart. In the line chart, the essential part is you need to have a column which is pertaining to date. Now line charts are always recommended to create using a date related field. Now I can have a time series or a line chart for the same number of records over here. In let me swap them, and I can make them as a line. You see I created a line chart, but this is not the correct way of representation of data. Why do I mean that? Now if you notice, this is a continuous representation of data now, which means there's a interconnection between this number 3 over here versus and the number 4. But in do in the reality, does that actually happen? The answer is no. Your first, or the value over here and the value over here may not be interconnected, right? So we do not have somewhere down the line in users assumption, they may depict it like, okay, it's interconnected, 2 and 3 is interconnected, or the values are going down. But in the actual sense, the values are not going down, they were, this value was already down, right? So this is how it was actually. So those kind of confusions do happen if you are using your x-axis as discrete. We should never do that, or I say I highly recommend you do not do that. What's a better way to do that? The better way is you have it as a date value. Now if I drag and drop any of the date value over here, you'll see I get the dates over here. Now we can play a lot with the dates. I'm just going to skip all that introduction. We have data for Jan through December, and now if I get any of the column over here, you see I got the date column. Now did you notice something? Earlier when I dragged and dropped, as I was mentioning earlier, let's say if I get something from region over here and I get a column which is sales, you see I got a bar column, bar chart. But here if I added a date and a column which is sum of sales, I got the value as a line chart. So that's the beauty of Tableau. Tableau is trying to give you a hint, or Tableau has built some internal intelligence in its engine where it tries to understand what kind of data type that you are trying to select, and based on that it's going to give you or going to suggest you saying that, hey, for given this set of information you can go for something called as line chart or something called as bar chart, right? So that's the way where we can also get a hint from Tableau to understand, okay, are we heading on the right path or not. Now again, even your line chart can be formatted to a great extent. You can add the values, you can add the colors to it, you can add the bifurcation of it. Now if I have to bifurcate this line into multiple points, like let's say I want to see, now these are the overall sales of your visualization of your sample superstore data that we have. But however, if I want to see it bifurcated by the region, we can take this region column and simply put it into your color shelf, right? And you will get the values, each one independent for each of the region. Now again, as I was mentioning, there are lots of formatting that we can do for this one and make it look much more better. But for now I'm just going to introduce you to this level of line chart so that you do not get bombarded with a lot of information. All right, so let's move to our next chart. Our next chart is a pie chart. Let me rename it as pie chart. All right, so what is a pie chart? Now pie chart is something, over here in a bar chart I was giving you a way in which you can compare the column wise, the length was proportion to the value. Now in pie chart it's going to be a circular representation of your data, and your circles will be sliced, and each of the area is called as a slice, similar to how you get your pizza and pizza is cut into the slices. Same thing happens with your pie chart where you can understand, okay, what is the slice area which is being consumed by a certain color, and based on that you can understand which is occupying the most amount of space or which is the highest contributor. Now to do a pie chart, what you can do is, there are multiple ways, but the simplest way is you just determine on which um, dimension you want to do, and you can just decide on what kind of measure you want to have. Now if you have noticed, I drag the value over here instead of the text box. That's absolutely fine, you can do that as well, right? And now I have this one. So the next step would be, I'll go to Tableau, show me, and I'll tell Tableau, hey, you know what, I want it as a pie chart, so can you please convert it? And I just instead of saying this, I just have to click on this one, and there you go, I got my pie chart ready. Now I'll just increase the size of this one by clicking on the entire view so that it occupies all the space of my screen. And to this one we can keep adding some of, so if you notice, things went off from here, like there's nothing in your row shelf or column shelf. Where did that go? It went into your mark shelf. Now everything is in the mark shelf, your keys are in the colors, and the sum of tempo is in your size and your angle as well. As I mentioned you earlier, there's a hidden card which is located in this place. This popped up now. It will come in some occasions depending on what kind of chart that you're selecting. Now over here it's asking you, okay, what kind of angles you want, and for that reason it's there, and it will use the measure to decide the angle of each of your slice. When I say angle, this one, it means like how much the slice should go up or down in its area, right? So that's decided. depending on your measure column, like the contribution. It just converts it into a percentage and it sees, okay, how much is the number, versus it converts it into the required number of radians and all, and it will give you that amount of slice. We don't have to worry for all that things. We just have to understand, okay, whenever we are creating a pie chart, we just need one dimension and at least one measure, period. That's it. Now I can also add lots of measures to this one. If let's say if I add over here, I can just add the playlist to create. Whoa, this is not something that I was expecting. Yeah, like this. So we can have the pie charts, each one for each one of them, but something which I do not recommend, or that's not something my personal I personally like, because it's really tough when you have to do a side by side pie comparisons. um, Let me just make them bigger. So if you see over here, like it's really hard to differentiate between which one is a bigger one, this one or this one, because it's difference in the area, and it's difference in the whole pie circle also. Like you see, this pie is a bigger one versus this one, because I believe the number of records for your rock anthem are much more high, lesser when compared to the 60s rock anthem. Now that's one of the pitfall you should avoid. Your users can, and it's statistically and it's also scientifically proven that when we are trying to give something for comparisons of area, we as a human being are not so experts, I would say, in differentiating or understanding, okay, this one is a bigger one or this one is a bigger one. It's really tough. So we should avoid this kind of charts where you have, it's like, in the multiple dimensions, which is also bigger in the size and bigger in the slice areas. So generally go for one dimension and one measure. I think that's the best way. But yeah, the choice is yours. So that's about the pie chart. Now I can again make it as entire view. We can also enable the labels as we did for the earlier one. You get the numerical numbers. It's generally recommended that whenever you give any pie chart, surround them with the percentages, so that even if a person who is looking at this chart is not understanding which one is the bigger one, yes, obviously numbers can help as well, but percentages serve the purpose in a much more better fashion, right? And we can also add the labels, like what does this mean. You can either keep them as a legend, or we can just drag and drop them again into this text table, and you will get the numbers over here. I can just drag this one as well, so that you see both of them. Now along with this number, I can also add a percentage, but that requires a small calculation, which is why I'm skipping it for now. So I'm not dealing with any of the calculation parts for now. I'm just trying to skip them, because there's a lot of introduction which has to be done for that, and a kind of um the some prerequisites you need to understand the calculations. When we are doing some calculations, there are uh, some things we have to understand. So as we dwell into the session and you get more familiar with Tableau, I think that's the time when you can be introduced to calculation and you feel more comfortable using them, right? So with that note, let's move on to our next chart, which is a pie chart. I'm sorry, pie we have already done. So we are going to do the next chart, which is called as the maps. Now map is a same geographical representation of your data. It's a very wonderful thing. The beauty of map is, I think Tableau was one of the few tools which started giving you map as an integrated behavior. Earlier it was like in any of the data visualization tool, you need a map. You will have to buy some third party apps or drivers, you have to incorporate them, and then you have to use it again. There were a lot of issues which were not user friendly. It will not give you all the things that you need, and lots many issues. So because Tableau is giving you all these features as an inbuilt mechanism, it is very easy to use, and it's like you will not find much of the difference when you are actually using any of the other visualizations versus this one. The only thing is, I believe, like if you are working on offline mode and if you do not have an internet connection, it will give you a irritating pop-up saying that you are not connected to internet, and thus you cannot have a live map. But that's okay. We can survive with that thing because it's only for the development purpose, right? So how can I create a map now? To create a map, you need a column which is geographical in nature or which has a geographical importance. Now, what do I mean by that? Now, in this song data, if you see, um, I do not have anything. Do I have anything which is called as locations? No, I don't have. So let me see it in the sample superstore. In the sample superstore, I have a column which is, now this is a hierarchy. Now, this is a hierarchy. Uh, let's not get there. But over here, if you see, the type of this columns is bit different. It looks like some globe symbols, so which means these are geographical columns. Now, each of this column in your data or in your database may or may not have the latitudes and longitudes captured, but it doesn't matter. Tableau will automatically assign the geographical coordinates to it. And in case if Tableau is failing to do that, let's say a column or name was incorrectly named there, like let's say instead of Hyderabad it was named as Hyderabad city in your data, so obviously Tableau cannot find it in the standard set of databases, so Tableau will throw you an error. But however, we have a mechanism where we can actually fix it. Now let's say, how does Tableau know this is a geographical column? The first thing is based on the name of the column. If the column is anywhere related to geography, let's say countries, states, cities, counties, districts, provinces, and many other things like which are directly a representation of the geography, it will understand and it will assign that particular level of geographical interpretation to that column. Now I can just drag this column over here, and you see Alabama, Arizona, and so on and so forth. Now, for this states, we have the latitudes. I can just put it over here in the text column, and the longitude as well, right? I can just put it over here. It's not getting into the measure columns, but for now, it's okay. Like this is just for your understanding purpose. So Alabama has the latitude and longitude like this, and so on and so forth. Now, if you drag and drop your dimensions, which are geographical columns, you will get the information in this fashion. However, let me clear everything, and I will just have to do one magical trick is, instead of dragging and dropping them, I just have to do a double click, and you see what happens. If I do a double click, automatically the longitude and latitude came and they fall into the columns and rows respectively, and your map is created, and you have your country and state already present over here. So it was like I did nothing, right? I'll just show you once again. So I just have to click on any of the new sheet, and I just do a double click. Now if I'm clicking in this hierarchy, the third value, which is city, Tableau is going to call country, state, and city, all the three things, into your detail shelf. Let's do that. Right? Now you see there's a country, there's a state, and there's a city. All those things are already captured, or they are called. Latitude and longitude is also called, and they are placed in your map, and you can see them. Right? That's the beauty. Now You can play with maps in much more different ways. All right. So we can do a lot of editing, or we can do a lot of things with your maps now. You can either keep them like this, or we can just select it as in your show me, and you can convert it into a symbol map as well, right? The beauty of the symbol map is it's going to acquire the whole space. I'm sorry, the filled map is going to acquire the whole space versus your symbol maps, which just keeps it as a point behavior. And I can make them look, now this is just a dimension representation. Adding the measures to it is like you just drag and drop this one into the color shelf. Boom, there you go. And you will have a beautiful representation of how each map looks like, or how each state looks like, right? So that's about a map. um, so again, there's a lots of things that you can do using a map, but I'm just going to give you an introduction for now, and we'll skip rest of the things so that we'll dwell into these features, the enhancements of this one in a later sessions, right? The next chart that we have over here is a tree map. uh, Tree map has nothing to do with the tree, right? That's kind of a funny thing. um, Again, let me bring the states over here, and I can show my sales in a bar format. But let's say if I do not want to show it in the regular bar format, what is the alternative? There are lots of alternatives, but what is one of the suggested by the Tableau? It's something called as tree maps. Now what do I mean by that? If I come to this show me and I click on this one, so it's like you have converted your pie into a rectangular box, and you are giving, so over here in the pie chart you had a circle, and each of them was a slice area. Similarly, in your um, tree map, everything is going to be rectangular, and you can have the boxes in a rectangular fashion. The beauty of this one is you can add more details to it. Like, let's say I'm looking at the state information, but I want to also see, or I want to divide this by regions. Now how can I do it? I can just get the regions and I can put them in the shelf. I have California over here. I'm sorry, this is the central region, this is the west region, this is the east region, central region, and the south region, right? So it automatically got segregated. So that's the beauty of having a tree map versus a pie chart. Tree map, you can use more than one dimension, versus a pie chart, it doesn't make logical approach if you're using more than one dimensions. We can certainly add lots of formatting things over here, like adding the labels and all. That's up to you, right? So let me rename this, and yeah, tree map. All right. Now, what's the next thing that we have on our list? The next thing that we have is histogram. Now, until here, we have dealt with this with the charts, which were um, very much familiar for you as a layman. But now we are going to have a chart which will need a little bit of statistical background to at least interpret. Means if you have a statistical background, or if your business user has a statistical background, they can interpret it in much more efficient way. Else, from a layman perspective also, they can still interpret it. It's not like they cannot, they can still do that. Now how do I do this? Histogram for Tableau is giving you a inbuilt mechanism. So histogram is used. So until now, what was happening is, you in all the situations, you had at least one dimension column, right? You were looking at the dimension columns, and you were looking at the values of it, and against those values we were trying to compare what is the um, proportion of each of the value, or what is the contribution of each of the value in terms of that specified measures, right? Now if you do not want to do that dimension comparison, let's say I want to this is one of the most common thing that we do when we are trying to do any numerical based analysis. Like, let's say I want to do a statistical analysis on understanding what's the most common number of products that people buy. Now let's say I'll give you one of the business example over here. Let's say I am a store owner and I want to create a situation where I want to give my users sales, some sale or a discount behavior, but I am obviously sales are there to increase the business revenue, right? Now I want to understand what is the most common number of products people buy from my store. Let me give you one example as a business user or a business owner. Let's say I want to set up a sale in my business, and I want to understand what is the most common number of quantity which uh, my end users are trying to get. All right, so let's see what how we can do this. All right, so let me take this quantity and let's see how I can make the histogram of it. So what I have to do is I'll just have to click on the show me over here, and for now I'm just going to click on this histogram button. I have it ready. So there's a some stat and there's some mathematics into this, but we will see them at a later point of time. So over here in your dimensions, you see there's a new column which is being generated, which has the symbol of the histogram again. And from here, I can decide if I have to increase or decrease my bins. And based on this, let's say um, I see the most number of commonly bought products are if I have to see what's the bin size, I can go over here. I can obviously make it from here as well, but for our understanding, I'll do a right click and I'll see over here. So my each of my bin size is 1.77. So let's make it more easy to understand. I'll make it as 2 and I'll say okay. And you see, so if I enable the labels, so highest number of people are buying the products which are between 2 and 4. So if I have to put a sale and if I have to increase my business, what I am going to do is I'll say you buy 3 products or you buy at least 5 products and you are eligible for a sale. If I want to cut short the competition more, I can say you buy anything more than 6 to 8 products and you are eligible for a sale, right? That's what the rationale goes. When if you see in these shops and malls, they'll say you buy 2500 minimum purchase and then you get some gift coupons or you get some gift items. That's the whole rationale which goes behind the scene. Now that's a that's your histogram. There's lots of things that we can do using a histogram. You can understand the kind of distribution, the skewness, and lots of things are there. But yeah, for now I'm not going to share all the things and confuse you for that. So this is your histogram. Yeah, and the next one over here is your scatter plot. Now uh, now we are getting much more interesting topics. Now earlier we had something where, okay, let me pull up a notepad over here. um, so earlier we had like set of dimensions where we had one dimension and one measure, and we used something called as bar charts, right? or or the line charts. However, if we had only one dimension, then we used something called as histogram. Let's say if I have more than one dimensions to compare and I want to emphasize a little bit more on the statistical behavior of it, how can I do that? We can go for something called as scatter plot. Right, what does a scatter plot do? Scatter plot gives you a side by side comparison, or it tries to give you a correlation between the two numerical columns. It tries to, like, if you have to find out if there is any relationship between the price of a product versus the purchase behavior of that, we can always see that. Or let's say the profits versus sales, like if my sales goes high, is it my profits will also go high, right? We can see those kind of comparisons. So for that, let me take this song data, and I think this will make more sense. Now I want to do a comparison. I want to see there's a column called as danceability and also the energy. Now I want to see how the danceability of a song versus the energy, like is there a direct relationship between them? I certainly feel from my um, inner feeling, like whenever you have a song which is high on energy, you generally tend to dance on that song more. But can we prove that with the data? Let's see. So what I can do is I can get this danceability into my columns and energy into my row shelf. Boom. Did you see something? Tableau is now not giving you a bar chart, but it's giving you something which is different, and it's like this is called as your scatter plot. Right? So Tableau is behaving a bit intelligent over here. However, what's happening over here is, it's if you have noticed, Tableau is trying to automatically aggregate all those columns. It's saying, hey, this all columns are, all the values in your database are combined, and this is called as the aggregated value. And this defines, okay, 11,929 is the total danceability score of all the songs put together. Now, if I want to see the bifurcation of this one, we can either just go and say unaggregate this one by using this analysis button over here and just unchecking the aggregate. That will get the unaggregated value. Now this is a bit messier, so I won't use this approach for now. But what I can do is I can go for the name of the artist, and I can put that into either my color shelf or my detail shelf. Now you see over here, there's a new shelf which has popped up, which is your shape shelf. Your Joker card. Now let me put it into the artist name, and you see I have a little bit less numbers. I think there are 7,564 artists that we have, and you see there's a strong relationship between the two things, like the energy versus danceability. As the energy goes high, the song is more and more eligible for your danceability. Now who is this artist? Kane West. Kane West songs are very high on energy and has a very high chance that you are going to dance on his song. Similarly, Lady Gaga, obviously you know that it's high on the energy, and hence it's high on the dance as well. So like this, you can do the analysis where you want to find out the correlation between the two things. Obviously there's another concept or the whole new discussion which says that, like, there's no, correlation is not necessarily the causation. But for the sake of our discussion, we can just limit ourselves that, okay, that there is a strong correlation between these two things, and certainly that has to do something. Now we can also do a lot of things over here. We can add the trend lines, we can group them, we can cluster them. um, we can find the trend lines, we can add some boundaries to it, and so many other things, right? For now, let's leave it until here. So that's your scatter plot. And this charts are really interesting. Like, as you start understanding them, as you start reading them, it's really it gives you lots of information, way more than what you can imagine. All right, so that's your scatter plot. And yeah, then you the final chart that I'm going to show over here is the donut. Now, donut chart needs a small calculation. This is going to be a add-on chart, but it needs a small calculation over here. So how do you do that calculation? You just have to do a right click over here, or click this caret symbol over here and say create the calculated field. Inside this calculated field, you will have to write a calculation which is called as dummy, which will have the value as average of 0. Now the reason why we take the average of 0 is we need a column over here, but we do not want it to be influenced by any of the filters, measures, or dimensions. That's why we take it as average of 0, so that it doesn't matter what mathematical operations you do to that, you add or plus minus, it again give you like all the numbers of all the zeros put together, the average is again going to be 0, right? So that's the reason we are going to use this dummy column over here. So step number one, what we have to do is we are going to create a simple pie chart. Let me use this regions over here, or maybe I can just use the songs data, and I can get this key over here, and I'll get the energy associated to it, and I'm going to click on the, I'm sorry, the pie chart. Now you see over here I have a beautiful pie chart over this one. So what I want to do is, what is a donut chart? Donut chart is the same as pie chart, but a center with no it's like center with the open space. So that's not possible in Tableau directly, so we use a workaround where we try to create a kind of illusion kind of a thing by using the similar color in the background with this one, so that it looks like it's actually a hollow space over there. And for this reason, over here I do not have anything to do my dual axis. So what I'm going to do is I'm going to create a dummy column over here. We can give any name to this one, but I will leave it for now as pi, and I'm just going to write over here the average of 0, and I'm going to put over here. Now you see what happens in the next thing, like if I add it twice, I'll have two pie charts over here, and that is what I want with this one. um, so for the second one, I'm going to remove all the things from my uh, this mark shelf. If you notice, like for each of this column I'm getting one independent mark shelf. So for the second one I'm going to remove all the things, and I'm going to reduce the size of this one so that it fits in the center. And the next thing that I'm going to do is I'm going to make it the color of the background, but before that let me do a right click on my second axis and hit the dual axis button. You see what happened? Now the values are just like it's overlapping, so let me increase the first one, so might be you will see and you can understand it much more better, right? Oops. Yeah, you see, now I just have to make this gray guy over here to the color of the back, whatever the color of the background is. It can be like white, black, or anything that you have done for your dashboard, so you can just select that one from this options over here. I'm going to make it as white, and tada, I have my pie chart ready. From a pie chart I have my donut chart ready. What's the beauty of this one is, we can, by normal I can have my energy over here as a split, I can have the name of it over here, and to make things more beautiful I can also give you a aggregation of all these values in the center, and I can say, hey, this is how it looks like, right? So that's additional information that you can share giving a donut chart, and also it looks a little bit more intuitive. If I have to show you how does it look like, yeah, this is how your pie chart will look like versus this is how your donut chart may look like, right? So that adds a little bit more beauty to your chart. So yeah, it's a great way to do that. All right, so that marks, or that makes me that makes the end of this session. So that's all we had for this session. Over here we saw the different charts, how you can create the different charts. There was some rationale which I have also shared, like how you can or what are the dimensions and measures that you need. Now how you can choose the charts based on this one, so you always have to understand what kind of dimensions you need and what kind of measures you have at your disposal, and you're going to merge them, and then you are going to see the probability, okay, based on this combination of dimensions and measures, we are going to use this particular set of visualization, right? So that's about your things. So we have seen how we can create the text tables, we have seen how you can create the bar charts, we have seen how we can create a line chart, we have also seen the histograms, the maps, the tree maps, the scatter plots, and finally we concluded it with the donut. Now this was just the start of it. There's a lots of things that we can do with these charts. We can do much more refinement to them. We can add much more value to it, but given the limitation of time, I think I'm going to, and also it's just the start, right? So as you keep exploring them, you will understand the more intricacies of it. So I don't want to bombard you with all that, so and hence I'm going to leave you with this one until here, so you can practice on this chart and you can try getting more understanding. And in the future sessions, I'm certainly going to add more details to this one and much more understanding on why only this chart and why do not anything else in that given situation. Quickly starting with what are the different type of filters we have. uh, so what first, let's see what do you mean by filters. So filters is a mechanism which helps your end users to slice and dice your data. Now your filters can be of various types, where your filters can be used to restrict some data which is actually flowing into Tableau's engine, while there are other filters which are used to hide some of the data from, like if you apply this filter, it gets uh, hidden from all the worksheets in a single instance, which can be also leveraged as a global filter as well. And the third one are the type of filters which you give the end users. The initial two were from a developer's perspective, where we try to suppress some data or we try to restrict some data, but the rest of the filters are the filters which we can extend to the end users, so that your end users can play around with those filters and make your dashboard more interactive, right? So with that note, so on this type of filters, we have various names to these filters, like extract filter, data source, context, dimension, measures, and table calc filters. Now, these are the names given by the Tableau themselves. So we are going to stick with these names, and we are going to understand what does each of this filter mean, where does it stand, and why is it named the way it is named currently, right? All right, so let's see what are the different type of filters, as I mentioned, and we will see. To start with, let's start with the extract filter first. So for this, let me navigate to our Tableau's workbook, and here I have connected myself to a SQL database where we have the various tables from a database named as Superstore US. Now in this tables, we have like we have, let's assume we have information which can be like, not all the information that we have in these tables will be necessary for us for our visualization, right? A very common example which happens in the real-time situation is you may have some tables which will have data, let's say for a very long period, let's say 5 years, 10 years, or 20 years, but your current project needs the analysis only for, let's say, 3 months or at the max of last 1 year. So in those kind of situations, we may have to cut short that unnecessary data. At the same time, we also have some situations where you will have way more columns than you need for this project. Let's say your dashboard or your table has 200 columns, out of which you just need 50 or 60 columns to do your analysis. So in those kind of situations, again, we have to trim that unnecessary column, so that the data which flows into Tableau's engine is of minimalist size. We are just keeping the data which is essential, and we are removing all the extra thing, so that the size of the file gets reduced and the performance of your dashboard increases significantly. All right, so with that note, so let's see the simplistic situation first. So whenever, let's say, you do not have to do any calculate, you do not have to restrict any data, you can simply drag and drop this over here, and you will have the data ready from this table. Now more about this on the joins and how you can use the physical layer, the logical layer. You can do the joins and unions and all these other methods we have seen in our previous session. So might be, yeah, you can have a look in that video if you want to have a recap. But for now, if let's say I want to restrict some amount of data from this visual, from this table, what I'll do is, instead of calling this table directly, I will use a mechanism which is called as custom SQL. All right. So whenever I drag this new custom SQL into this data pane over here, we will have an option to write a query. Now the beauty of this one, this custom SQL, is it works with all the databases. So if you are working on a SQL database, it will follow the syntax and semantics of a SQL database. If you are connected to, let's say, a Oracle database, it will follow the semantics of Oracle database, and so on. Right. So as I'm connected now to a Microsoft SQL server, so I'm going to use the SQL server principles which are adhering to Microsoft. Here I won't be writing much of the query, but just to share it with you. So let's see first what all table columns I have, for which I can just write over here, select star from orders, because I want the data from the orders table. So I can just say OK, and in the bottom of the screen I can see it in the preview menu, preview pane. But here I have an alternative where, especially for this custom SQL, so whenever you write any SQL code and you want to validate, okay, the code that you have written is working appropriately, we can just click on this preview result over here, and we will get an output where you can see how many number of records are coming, or if the records are coming or not in the first place, and so on. All right. So because it's the first time I'm doing it, may take few moments to load, so just wait for it. It should not take so long, but yeah, let's wait for it. Wow, it's still loading. And yeah, beautifully. So finally, so I have a table over here which shows you all the values, all the columns that we have over here. So I have columns ranging from category, city, country, customer ID, and so on and so forth. We have region, segments, and so on. So let's see if we can restrict our data based on let's say region, where we can find out if so now I have data for region central, west, east, and south. All right. So let's see if we can restrict the data only for the south region. So what I'll do is I'll add a where condition over here, and I'll say where the region is equals to south. Right. And if I click on OK now, it's again going to execute the query, and now it's going to restrict the data only to the south region. And now if I go to my region column over here, you see I have the data which is only related to south. Right. So this is how you can apply the extract filter. So here I just applied a row level filter, but however, if I want to restrict my column information, instead of using a star, I can define what all columns I want. I can just say I need a category filter separated by, let's say, city, and then let's say state, and I'll call some sales, and let's say profits. Right. Let's see if I have called all the columns correctly. If I hit on preview, okay, it says some error, which means I have written some of the name of the column incorrectly. There you go. So here you see, okay, I have the columns now which are only restricted to category, city, state, profit, and sales. And even though my region column is not available, it is still restricting that data on the region column. So whatever the column condition that you write in your where condition need not necessarily need to have in your output. If you want to, it's okay, but if you do not want, you can always skip it, right? So let me leave it with this, and if I say okay, and now you see over here I will get the data, and if I say update now, I will get the data the same way what I got it in the preview result, right? So this is called as your extract filter. Extract filter has a significance, and it's a very important filter for the very reason it restricts the data, it avoids all the unnecessary data, and thus helps you to increase the performance and also helps you to reduce the size of the file. So it's not from your operation perspective, but just because your file size has been reduced, the operation or your performance will increase, right? The second one over here is in the list we have is your data source filter. Now what does data source filter do is it's an alternative for your extract filter to a certain extent, where it suppresses the information. It does not restrict the information from flowing into Tableau's environment. Now if you see over here, I have the data which is for category, city, state, and sales and profit. Now let's say out of this I want to restrict my data only to a state which is, let's say I want to restrict only for Florida, right? Now what I will do over here is I can go to this filter interface over here, the one which is on this right hand side top, where I can just click on this add filters. So if you see, there are no filters for now, and hence the number or the count is 0. But if I click on this add filter option over here, it gives me a new window where it says edit the data source filters, right? Here I can click on this add button, and Tableau asks me the next question. Okay, you have this many columns listed in your data, so which filter or which column do you want to use as a filter? So I'll select it as state and say okay. And now over here I have the exhaustive list of all the columns or all the values that we have in this column. So out of which I said I just want to restrict the data to Florida, so I can just click on the Florida option over here. Alternatively, if I want, like, out of all this 11 values I do not want the Florida value, so I can just click on all and I can just click on Florida as an exclude, and I can restrict the data. Vice versa, I can also do, I can just select the Florida and I can select on the exclude button. Now these are the various ways in which you can play around with the data. That choice is up to you, depending on how many values you want to select versus how many values you want to exclude. You can always take a cautious call, right? So for now I can just do it other way around, where I'm just going to select the Florida as a value, and I'm going to say okay and say okay over here. So you see, and if I click on update now, I get the data which is only restricted to the Florida state, right? Now this is also one of the very common interview question that comes up: what is the difference between a data source and extract filter? So have a note on this one always, guys, right? Now the third filter in our order is the context filter, but I'm going to skip that for a moment, and we are going to look at the next filters, and then we'll come back to the context filter. So let's see, what do you mean by a dimension filter over here? Now once we are done with this page, once we are ready with this page, we will move to the next page where we can do the actual visualization. And all these filters over here, the context filter, dimension filter, measure, and table calc filters, these are the filters which can allow you to restrict some data on the go, so that and it can be optional. It can be, you can suppress a data within a sheet or a group of sheets or all the worksheet at once. Now the second benefit that we have with these filters is you can extend these filters and share them with the end users as well. So you as a developer, you need not need to keep it to yourself, but you can pass these filters to your end users and they can slice and dice your data as well. So let's see how does that work. Now if I go back to my sheet number 1, so instead of superstore data, because it has very limited columns, I'm going to use some other database over here, which is, let's say I want to see songs data, right? In the songs data I want to see, let's say I have here the various values in the dimensions and measures. So in our previous class, we have also seen when we were creating the charts, we have seen what do you mean by a dimension and what do you mean by a measure. A quick recap is all your non-numerical columns are your dimensions. All the numeric columns are measures. Whenever you call a dimension, it gives you the unique value out of those dimensions. On the other hand, whenever you get any of the measure column, it aggregates those column and gives you most of the times in a default behavior of sum as an aggregation and tells you what is the total value against this each of the dimension in case if you are getting it into your visualization. We have also seen about the worksheets and how to create a chart. So whenever you drag and drop any of the dimension and if you drag and drop any of the measure over here, you will see a bar chart by default if you are using a non if you are using a simple categorical column and a simple measure to create this chart. Now there's some logic which goes behind the scene. I think I have discussed it again in our charts section. We can have a look why it was only bar and why not anything else. But coming back to today's topic, so what I can do here is I just sorted the data and I will enable the labels so that we can see okay how things are going on. Now that I have the playlist, I want to see who are the artists associated with each of this playlist as well. So what I can do is I can get the artist name over here and I will see the split of my playlist by the artist name. So let's say now I want to do analysis. I want to see what is the playlist. Let me select something from over here. Um, or I can see what is the exhaustive list over here by just saying the show filter, which comes on to my left hand side. And let's say I just scroll down to something. Let me uncheck all of them and I can select one of them, which is the bachata classics, right? So we can see okay what are all the values that we have within the bachata. So who are all the artists, and if I sort it from top to bottom, I see okay there are nearly 18 artists who are having the playlist, who are part of the playlist which is part of the bachata, right? Now over here, so what I did is I created a filter by just doing a right click on one of my dimensions over here. The alternative for this one is I can get rid of this one for now by dragging this field out of the filter shelf, and I can add it back from my normal filter from my data pane. What I can do is I can take this playlist and I can drag it into this filter pane over here, and I will have the list once again listed over here, from where I can just say none and I can just scroll down, or I can also search it over here by searching for bachata, and I click on the bachata over here and say apply and OK, right? In this instance, you might notice there is no filter option onto your right hand side. If I want to have a filter selected and also to have the dialog box representing here in the right hand side, what I can do is I can just do a right click and I say show filter, right? If I do this right click and show filter, automatically a window a dimension is going to sit in my filter shelf and I will have the playlist listed over here. Now I can again search for bachata from here and I can have the values listed here. Now because I was dealing with the dimension filter, this filter is called as dimension filter. Now if I would have been using sum of energy as a filter, it would have been called as a measure filter. Now again the same trick, I can do a right click over here and I can say show it as a filter, or I can also do a right click on my energy column over here in my data pane and I can say it as show filter. And you see I have my sum of energy listed over here where I can see all the values. If I remove this filter, it's from 0 to 262.9. Now this is the exhaustive list which has the maximum values even before your bachata was added. Now, let's say I want to have values which are all about this 1.010. So what I can do is I can write it over here saying that give me values which are all above 1.01. And you see, I have now values instead of 18, I have 12 artists who have the song range which is between 1.0 to 7.8. Right over here I can get rid of this 262 and I can have only the maximum values over here by just clicking on this drop down over here, and I can say only the relevant values. And okay, it doesn't appear over here, my bad. But yes, we can do that as well, and I'm going to show you how does that happen as well. Right, so here for now, if I remove the filter, I got it from 0.395 to 7.83, which is the normal behavior, but I think it is now using the only relevant values. All right, so that's about your measure filter, guys. So the first one was your dimension filter. The very reason I called it as dimension filter was it's because the values are coming from dimension. If I'm calling the values from or filter from a measure, it is called as a measure filter. Now your dimension and measure filters need to behave only in this fashion. There are various ways in which we can apply it. How we can do is, let's explore first one for the dimension filter. If I click it on the edit filter over here, I have the wide variety of options where I can select directly from these values over here. Like I can just keep on selecting the values that I want, but you see over here I have nearly 300 values. Now selecting the values which are out of 300, it's kind of not so easy job, and you don't even have a assurance that whatever the values that you have selected are going to stay there forever and won't get upgraded or downgraded. Let's say in some situations, if you want to, out of this selection that I have, let's say I want to find out all the values which are having some word which is called as good, and I want this filter so that even not just now, even in the future, if the playlist updates and if there are any other values which are coming up with the name as good, that should be included as well. So for this situations, what we can do is, instead of the general, I can go for the wildcard match. In the wildcard, I can select the option as good, and I say if it contains the word good, give me the output. Similarly, we can have for the various things like starts with or ends with or the exact matches, depending on what kind of business problem are we trying to solve. Are we looking to have values where it starts with only this name? A common example I can say is, generally if we are trying to validate, let's say, the email IDs, if you want to see if all the users have given you the email IDs which are pertaining to your company, then we can search for ends with and say wherever it ends with, let's say I want to see for Gmail, I say oh, ends with @gmail.com over here. So it is going to search for all the values which are only related to the gmail.com. Exact match is something bit scary. You do not go for it because it gives you a very narrowed down search. So even if there's a slight change, it doesn't pick up. So generally we use the contains as one of the most common thing. So let me see if I can use the good as a keyword over here and I can try to find something. If I click on apply, I have the all the playlist which has the name good inside it, right? So this is the second way. If I remove the artist name, might be things will be more clear. And if I just sort it, I have feeling good, it's a hella good, it's all good, and good vibes, and so on. Now that's kind of another way as well. Let me get back this artist name. Now the third way in which you can do is, instead of wildcard, we can also use, let me just get rid of this one. We can also use a condition matrix where we can define some condition saying that based on the energy, if the values are above a certain value, you can use it. and this need not necessarily have to be the part of the or the column which is there in your visualization, but it can be any other column as well. Let's say it is a column like acousticness or the album names or your instrumentalness or any other column that you have. But from a practical perspective, I have seen we do not use this condition very often because of the various limitations that it comes with. um, so I would recommend you, based on my experience, do not leverage this exception or this as a option, the condition as an option to restrict your data, unless you are exhausted with all the other alternatives. If you can use a calculation where you can write a calculated field and get that into the Tableau's filter pane, it serves more beneficiary, and it's more effective. There are few certain foolproof. It's like you're making it a little bit more foolproof. That's it, right? So you have it, you can use it, but if you wish, but my suggestion, you can avoid it. The final one over here is the top. Again, the top is also one of the same things. It's there, but somehow I do not encourage it because there are few situations where it tries to act cranky. Now, let me see if I can get you that example. Let's say I'm trying to see the artist names out of this feeling good. If I have to find only the top five, I can very well do it. And you see, I have selected the values as 5, but I am getting over here only 2 values. Okay, let me go back and do it again. What I did is I said, out of this artist names that I have, I want only top 5 as the result, right? And I'm doing it here again. I select top 5, and the values are based on the sum of energy, and I say apply and OK. You see, I had more than 5 values, so in the idealistic situation I should have got all the 5 values over here. Now why is it not coming? Because of the way it is executing. So here, this is one of the main thing which I wanted to emphasize on in today's session. So this is a common pitfall where I have seen lots of developers face challenge. What happens is, like, you have something in your mind that I'm going to use artist name as a filter, and I'm going to use top 5 as a filter criteria, and I'm going to give you the output. But the moment you try to apply that filter, instead of 5 it just gives you 2. At times it gives you 1 or 4 or 6, and the value depends. Like 6 is a different criteria. It comes generally when we are dealing with rank, but most of the times when we are dealing with the sum and those kind of things, it gives you a lesser value than what you expect. Now why is this happening? For the very reason, what Tableau is doing is Tableau is sorting your data first, and it is applying the filters later. How do I justify this one? I'm going to recreate this whole chart once again over here by taking the playlist, artist names, playlist, and the artist names, and then I'm going to get my energy column over here. And now if I sort it from top to bottom, or let me remove this playlist for a moment, and now if I try to apply this filters over here which says top 5 by energy, I get all these people over here, right? I have Drake, Lil Wayne, Travis Scott, Khalid, and Kanye West. And let's see over here, I have Kanye West and Khalid only. Why? Because over here, against this artist names, if I apply this playlist option, you see these people are from the different filters. They are from the different filters and not from the filter of your playlist where I have applied a filter of good, right? Now this filter is being applied first, or it's being applied later. Before that filter, your top 5 filter is getting applied, right? So if I have to adhere to this situation, number one is we can use some alternatives to do it, or we can simply tell Tableau that, hey, you know what, I want this top 5 filter to be applied later. First apply my playlist filter. First apply my playlist filter where I get only the good as output. And once this filter is applied, then I want you to apply a filter on the artist name which gives you only the top 5. And how do I tell Tableau to do this kind of thing? I will have to convert my dimension filter into a context filter. It's like you're promoting that filter. Now if I do a right click on this one and I say or add to context, you see my values. Now I will get the top 5 values. It may be more than 5 because 1 2 3 4 5, or let me remove this playlist from here, and you see I have 1 2 3 4 5 values over here, right? So that's the beauty of promoting your filter from dimension filter to a context filter. Let me quickly walk you through again in case if you just missed on that. So what did I do is I'm changing the normal logical behavior of Tableau. Earlier what was happening is, let's say I have a set of values in which I have, let's say, certain amount of records and certain number of columns, out of which a certain column is being applied first, and whatever it's, let's say in the second instance I have, let's say, only this much amount of data which is being restricted, right? I apply one more filter and I get my data restricted on this one, and my second filter will also work parallelly along with my first filter in this instances, right? However, I want to change this behavior. I do not want all the filters to be applied in a single situation. Now, this situation is somewhat similar to how we write a AND condition in a programming, like let's say A and B. So here A and B are going to work simultaneously. They are not going to work independently, but going to work simultaneously. So I want they should not work in a simultaneous fashion. I want A should be applied first, and whatever is the result of A, my B value or the B filter should work, right? So this is my overall data on which I am applying the A as a filter. First, the resultant data. So out of this one, this is my resultant data. On the resultant data, I am applying my B filter, right? So if we are trying to get this kind of behavior, this can be achieved very easily using a context filter. And why do we do that? As I have showed you over here, there are certain situations where you have to change the priority of a filter so that all the values do appear on your screen, or the rest of the filters work in the way they are listed. Now in the later point of session you are also going to see something called as level of detail filters. In level of detail filters you have there are certain complications for which you may have to promote your filters once again to the context as well. I'm not going to dwell into that a lot, but yes, in the subsequent sessions you are going to learn about that thing as well. Now that's about your dimension filters, your measure filters, and your context filters. All right. The last one is about your table calc filters, where you can use some table calculations to restrict the data or to play around with your data. I'm not going to do much more dwelling into this one, for the very reason for that you will have to understand what do you mean by the calculations, what do you mean by the table calculations, and on those things, right? So let me take you to the next set of information, where now this was all from your developer's perspective. What we did is, from the developer's perspective, number one is we were applying a filter, or we were applying a context filter where we are trying to decide the hierarchy of the filters. Now we will look from the end user's perspective. Let's say if I have to share this filters to my end user, where my end user can select these filters, change the filters, and work with the dashboard, how does that look like? For that, what I can do is, so this filters over here onto your left hand side are the filters which will be used by your end users, right? So I can just remove this one and I can just do a reset to all the filters that we have. Clear filter, I'm going to clear this filter as well, and I'm going to clear this filter as well, so that we have nothing over here. And then I'm going to call each of the filter individually. Let's say show filter, secondly show filter, and the third one show filter, and one more I will add, the key filters, key over here, right? Show as a filter. Now if you have noticed a slight change over here, the artist name came up in a little bit different fashion from the way we have all the other filters over here. Now all the other filters are checkboxes. Checkboxes allow you to select filters more than one value at a time, right? However, this one is a text box where you can enter a value and you can search for this people. Like let's say I want to search the artist Drake, so I can just type a Drake over here and I can search for Drake, and it will tell me, hey, in your data you have two people with the name Drake, so which one you want to select. So if I do a selection over here, I get the values which are only related to Drake, right? So this is called as a wildcard search. Let me just remove this one and this one, and over here if I do this, so every filter that we have, so by default my artist name was changed to wildcard for the very reason I have 7,000 unique artists over here. You see, I have 7,000 unique artists, and if you imagine I am giving 7,000 unique artists as a display value in my filter, it is going to change, or it's going to affect my performance of a dashboard big time. So to avoid that kind of situations, we leverage wildcard search. Now we can also use this filters as directly as simple as checkboxes, or if we want to get rid of these checkboxes and get something more nicer, we can just click on this drop down over here, which is also called as the caret. On this caret, if I click, I have this different values as single value list, single value drop down, or the slider, or the multiple value list, and the wildcard match. Now we have these options, but let's say if I want only one value to be selected at once, we use the option of radio buttons. Now that's the difference between a radio button and a checkbox, right? A radio button allows you to select only one value at a time. You cannot select two values or more than one value at a time. Checkboxes gives you that feature. So let's say if I click on radio buttons over here, it will take a moment, but this is how it will look like. So I can just click on 1, 2 and so on, or I can just have all over here. All is also just a single value, but it takes the criteria that all the values should be included, but it doesn't mean that I'm selecting more than one value at once. I'm still selecting only one value at once, right? How did this all came here? So all is inbuilt Tableau's filter feature, which whenever you add any filter, it gives you this all button over here by default. You don't want it, we can get rid of it by just going to this drop down once again and by doing the customization. And if I say I don't want the all as a value, I can get rid of this all button over here. Now let's say whenever I'm trying to do some changes and I feel my dashboard is taking a lot of time to render, let's say using this album names over here, let's say it takes a lot of time for me to uncheck all and select one by one at a time, and it's not so good thing. What I can do is I can go to the customization once again. I can select this customize button and I can select, or I can enable this show apply button. So what does it do is it gives your users the feature or the benefit of selecting multiple values at once, And let's say now that I have selected more than one value and I'm satisfied with whatever the selection I want to do, I can just click on this apply button and I will get only the values which I have selected, right? So this eases up um, the the rendering time. So many a times if you see, there will be few dashboards or which will be like, they work a bit slow. So and you do not want it to keep on refreshing every now and then, so we can give this kind of all button or the apply button as a feature, so that the number of times the page get rendered is lesser than the normal thing. Now the other options that we have over here is the slider. We can have a slider option for a text as well, but I recommend you not to do it, because imagine if I have a slider option over here and I literally don't know what are all the available options over here, and if, let's say, if I have to move from 1 to 10th value, it's actually not a good thing. It's something where, your end users are going to find a lot of difficulty, right? So I personally feel, or my advice is, do not use the slider with categorical data. You can use it with the numerical data at its best. To a certain extent, we can use it with the date column, where you have January, February, March, those kind of things. It's going to be exhaustive list of max of 12 months. It cannot go beyond it, and all the users will know, okay, after the March it will be April, and so on. So in those kind of situations, we can use the slider as well, but for the text columns, I strongly encourage you not to use it, right? It's just from the ease of usage, or it's like from we are trying to make our users experience as seamless as it can be, right? So we, all these options we are trying to change and make do it. It's for the seamless experience of your users. Now the other option that we have over here is, like, instead of, let's say, having such a big list over here which consumes a significant amount of space, I don't want them. What I can do is I can use the drop down options, even for the single value or for the multiple value. I can select this drop down so that this filter collapses into the minimalistic space, and whenever I want something, I can click on this all, and I'll have the exhaustive list from which I can select the values as per my choice, something like this, and I can click on apply, and my filter goes off, right? So that's how we can play around with your filters. We can give this many different behaviors to your end users. We can also give the custom list or the wildcard match, and over here you have the option of only relevant values versus all values in database. Where is this useful? It's useful when you have something like, let me use another example over here. Let's say I have this category as a data, and let's say I have this subcategory as a data. Now, if I am trying to apply a filter over here, and imagine a user is trying to apply filters like, now you see furniture is comprised of bookcases, chairs, furnitures, and tables. What happens if I select furniture as a filter, and instead of selecting the values from this four values, I select something as accessories or arts, my output is going to come as 0. Why? Because again, as I mentioned a while ago, your conditions work in a and condition, right? So it is going to search for furniture as a category and subcategory as arts. Now wherever we have arts, we do not have furniture, and wherever we have furniture, we do not have arts, right? So in case, to avoid this kind of confusion, or to avoid this kind of dead ends to our end users, what we can do is we can use this option of only relevant values. So what happens is, if I select this only relevant values, now you see my subcategory is going to give me only the values which are related to my first selection. So if I just select office supplies, I get appliances, arts through supplies. And if I select technology, I get the values which are only associated to technology. So that makes your user from you can avoid your user from selecting some unwanted or unrelated values. Now, and this is a two-way thing. You can either select, you can make it for your category as well, so that if I select the values as accessories over here, the phones over here, and the tables, let's say, yeah, tables, so it will tell, hey, the selection that you have done is part of two categories. If I uncheck tables, I get it only from the technology, right? In this way, we can restrict our filter playing, or we can make it more user friendly by selecting the option only relevant. Include exclude is the same thing which I shared earlier. Like, in case if you have an exhaustive list, and you by default it's going to be include, and that's how it should be to the great extent. I feel having exclude is not a very good behavior. I'll show you why. You see over here, like if I'm using the exclude button, it strikes out, right? It strikes out that technology, it strikes out the furniture. It doesn't look so good. So for that reason, what we can do is we can simply use the include, and your user can, in fact, they can just uncheck these values and keep the office supply and make it look more beautiful, right? So in case of there's a situation where it's like you do not have an alternative and your client needs it, you can certainly use it, but again, it's not a very good behavior to keep it, right? So that's from the user interface. So what did we see? First thing we saw is, let me just type it over here. So first thing that we saw over here was how you as a developer can apply a filters, right? Or play with filters. The second one we saw is how your end user experience can be altered using the different behavior of your filters. The third thing we are going to see over here is going to be the application of the filters, like, or the uh, application in the sense, is it going to work only on a single worksheet, is it going to work on more than one worksheet, or is it going to work on all the worksheets that we have. Now how does that happen? For that we will just let me start my laptop charger over here. Yeah, so how does this work is, your application of filter can be done using the filters which are there in the filter shelf. You just have to do a right click on this one, and you have to say on how does this filter work, like is it going to apply only to a worksheet, all using these data sources, all using the related data sources. And I think there should be one more option which is selected worksheets, but I think because we have created only one worksheet out of the sample superstore, we don't have this option over here where it says selected worksheets. So let me just duplicate the sheet couple of times. Sheet 3233, you see over here I have duplicated the sheets. Now if I go back here, I will have the option of selected worksheets as well. Now what does each of this mean is, first one, only this worksheet means you are localizing that filter, you are restricting a filter to only a single filter, right? However, if I use a selected worksheet, it gives me a range of filters where I can select the data from more than one but not all, or I can select all also, but the difference is, here we cannot apply it to any sheets which are not from the same database. That's one. The sheet 1 to 4, I believe they are empty, because of which they are not highlighted over here. And the second option, or the third limitation, that is when we are doing this all worksheets from over here, is if I create a new worksheet over here, let's say I'm creating a new worksheet which is, let's say again, the categories by, let's say, the pivot field values over here. So this filter is not going to apply on sheet number 8, right? The category filter is not going to apply on sheet number 8. It's going to be a blank over here. Now if I have to apply the filters not only restricted to the current filters or the current worksheets, but I want this filter to be applied to all the sheets that are there using this data source. I can click on this option over here saying that all using this data source. Now you see the symbol changed little bit. I can do one thing. I can just add one more filter over here. Let's say region as a filter. So what I'm going to do is I'm going to leave region as a subcategory. I'm going to apply to more than one worksheet over here. I'm going to apply to, let's say, 3 worksheets, and I'm going to apply this category to all the worksheets, right, using a data source. And I'm going to call one more filter over here, which is, let's say, a state, and I'm going to say it as show as a filter, and this one I'm going to apply as a all using related data sources. Now why did I do this? To showcase one beautiful feature over here. You will have a prefix of filters, icons, the prefix of icons listed over here to give you as a developer the understanding what is the behavior this filter is into. Is it like only one worksheet? There won't be any filter icon associated to it. If it's more than one but not all using this data source, then it's kind of a pile of paper symbol. The third one is a data source filter, which is only a single cylinder, and all using this related data sources is like, now this filter state won't be restricted only to the sample superstore, but it will extend its behavior to the charts which are being created based out of song database or even your superstore US database, right? So that's the uh, behavior where we can extend a filter beyond a single data source. Now this is from your application of a filter perspective. Now what is the final way? The final way is how we can give these filters on a dashboard to your end users. It's the same thing what we have just seen over here, but we are going to make them apply on a filter on your dashboard. So for that, what I'm going to do is I'm going to quickly create some worksheets over here. So I'm going to take this, let's say I have this one over here. I'm going to create a map, let's say on a state, so that we have a map sheet over here. And I'm going to create one more pie chart for, let's say, for segments by the order count, and I'm going to go to the show me and I'm going to create a pie chart. I'm going to make it as entire view and enable the labels for it and also the segment values to it, right? So I have few charts over here. Now these charts are not of the significance, the behavior of the filter is going to be the significance. So what I'm going to do is I'm going to add them into my dashboard, and I'm going to call each one of them over here by dragging and dropping. So whenever I drag and drop these filters, if I have any of the filters listed over here, like for example in my sheet number 3 or 4, I have 4 filters which are visible on my right hand side. If I have these filters visible on the right hand side and I call this worksheet over here, you see what happens? Onto my left hand side, I get all those filters into my dashboard. Now I can just get rid of this segment legends and this legend over here. I have all these filters listed over here now. Now I can either do a right click on this one. I can also change the behavior from here. I can just make them as multiple value drop down so that they don't consume a lot of space. I can make it multiple value drop down, again the multiple value drop down, and the final one multiple value drop down as well. Now might be in the other session I have explained, or I may explain you about the containers and all the things, but for now I'm just going to add them over here. I'm going to call all these filters into this container so that they come in this vertical position here by just dragging and dropping it. And I'm going to make it distribute evenly and just make it over here on the top and enable it. So now you have all these filters over here. Now out of these filters, I have few filters which are applicable only to a certain worksheet. for example region. So if I click on the region filter over here, you see nothing changes except for my sheet 3 or 4, right? My second filter over here, which is subcategory, is applied to more than one but not to all. So if I click on uncheck all, it's again going to apply only to sheet of 3 or 4 because I don't have sheet of 3 and sheet of 2. So I can just get this one over here, and you see this is applied to more than one worksheet but not to all. The third one over here is category filter, which is applied to all the sheets that we have over here. Now if I uncheck all from here, you see it gets applied to all the sheets that we have on the dashboard. Similarly, your state as well. In case if you have only one database, then all using the data source and all using your related data source works exactly the same way. Okay, so this is from your dashboard perspective, how you can add your filters. In case let's say there was no filter in your worksheet, or let's say there's a filter which you have added lately. Now let's say I go to this map and I say I want a new filter over here as let's say city as a filter, and I'm going to say show filter. Now this filter over here is not going to update into your dashboard automatically. For that, what you have to do is wherever the filter that you have called, you have to go to that worksheet, click on this small caret icon over here and click on this filters and get that filter enabled. So let's say I click on this city filter. You see I got my city filter over here. Now again it's in the list column, list option, so I am going to change it from list to drop down option, and you see I have my list over here, the drop downs for each of the filters as I want it, right? Now the final one over here is making your dashboard interactive. How can I make my dashboard more interactive? We can enable something called as action filters. So I'm just hiding those normal filters. What we can do is, if we click on this worksheets, we have this small icon over here which is looks like a funnel or a filter kind of a thing. Now if I click on this one, and let's say now if I click on North Dakota, you see all of my dashboard gives me values which are only pertaining to North Dakota. Similarly, I select on Texas over here, you see my home office changed to 596. If I uncheck, it gives me the value as 7132. So this means that I can make all my dashboard, all of my charts interactive in nature. Let me do it for this pie chart. Now if I click only on the home office, I will see the analysis. So here it's not enabled or visible. So let me change it to something else. I can make it as filled map, and I can enable the labels, and I can also add some let's say the order count into the color shelf so that we see the variation. Now if I click on this one over here, you see it's like for Montana we have 60. If I click on home office, I'll get it as 36, right? So we can make our dashboard as much intuitive as we want. There's a lot of things that we can do with the navigation options over here. Like you click on a certain sheet and it goes to the next dashboard. It can just go to the next dashboard. It can also filter the next dashboard. Like means if I am on this worksheet and I'm clicking on the home office over here, it will automatically navigate to a new dashboard which is already created, and in this it will filter. Let's say I have this maps over here, right? So let's say I have the maps over here, and if I click on this home office over here, my whole map will get drill down value only to the home office. We can also use it for navigating between two worksheets or more than two dashboards. We can also use this action filters to create update the parameters or use it as a URL or to go to a certain worksheet. These are all lot many things that we can do using this navigation or the action filters, but we are going to cover all of them in the later session, so we can see it over there. right? So that brings us to end of today's session. So let's have a quick recap on what just we saw. So we started with the extract filters. We saw what do we mean by a filter. So there are various filters we have. Filters help you to navigate or slice and dice your dashboard and your data so you can make more insightful analysis. For this, we have the different set of filters like extract filter, data source, context, and so on. Extract filter helps you to restrict the data to only what we need, so we can cut short all the unnecessary data from entering into Tableau space. Data source filters over here helps you to suppress some of the unnecessary data which you have in your dashboard already, but let's say you want to avoid them for some instance, for some reason, might be you want it for the later part and you do not want it now. You can use it as a data source filter, or even in the later pages where we made the filters across the dashboard get applied, it was the same data source filter which we have used. The third one is your context filter, which is like you're promoting your either of your dimension or measure filters a level above, so that all of the other filters are working on the result of what is your context filter. Then you also have your dimension filters and measure filters. As the name indicates, if you're calling a column from dimensions, it's called as dimension. If you call a column from your measures, you call it as a measure filter. Table calc filters are the filters where we have something called as table calculations, which we can imbibe into your filters and make it work. And finally, which we haven't covered in this session, but we may cover it in our later sessions. And finally, we have seen a dashboard in which we can create actions and we can make them interactive. Now here's an idea that I want to give it to you. Use the previous three sessions as a base. Take some data, do some joining method, create some charts, apply this filter, and create a dashboard the way I have created this dashboard, and start playing with these filters. You will understand what kind of filters are they behaving, how they are behaving, and what you can do with the actions, right? So and little bit more detail of the actions and all the things we can do it in our later sessions. So yeah, that brings to the end of this session. So I hope you guys understood the how filter works, what is the way it handles behind the scene, and also I hope that you will use it in a better way, so that you, when you create a dashboard, you take more educated guess that okay, if I'm using a context filter, how will it work versus how you could have worked it in the normal instances, right? So if you have liked this session, please like, share, subscribe to this session, because we are going to upload many more sessions, and we are also going to get here some of the industry experts where we will have a live sessions where they are going to share their experiences, their expertise with you. To get the notifications of this sessions and the all the playlists that we are going to upload, do like and keep it subscribed. And with that note, thank you so much guys. See you in our next video. Bye bye.